So let's get started with this course and with everything you need to know about JavaScript by diving into this important question. What is JavaScript? Let's have a look at a couple of definitions. JavaScript is a dynamic, weakly typed programming language which is compiled at runtime. It can be executed as part of a web page in a browser or directly on any machine in a so-called host environment. Okay. Not entirely clear yet? Let's have a look at an additional definition. JavaScript was created to make web pages more dynamic. That's kind of the idea why JavaScript was invented in the past, you could say. More about the history of JavaScript in a second, by the way. So it was invented to change the content on a page directly from inside the browser. And originally, it was called LiveScript, but due to the popularity of Java back at the time, it was renamed to JavaScript to resemble Java by its name. JavaScript, however, is totally independent from Java. That's important to understand and has nothing in common. It really was just named JavaScript because, well, Java was popular and, people who invented JavaScript wanted JavaScript to be a thing, I guess. But I'm not sure. Are these definitions really clear? Do you now know what JavaScript is? Does dynamic, weakly typed, compiled at runtime make web pages more dynamic? Does this tell you something? Well, let's take a step back maybe. How do web pages work? You are the user visiting a web page, and when you do visit a web page, you use a browser for that. You use your client, your machine, your laptop, your computer, where you have a browser installed on it. You enter a URL or click on a search result on Google, and the web page gets loaded. To be precise, when you initially visit a web page, a request is sent to the server, so to a computer in the internet where that web page, where the HTML file is hosted, and that server then loads that web page and sends it back to your browser in a so-called response. And the most basic form of response we know or we typically see and use when we work with the internet, when we visit a page, is simply an HTML page which is sent back by the server to the client. Now let's say on that loaded web page, let's say it's an online shop, doesn't really matter, the user clicks a button to submit a form. For example, to order some products. Now this will then trigger a new request which is sent by the browser to the server to send this form submission to the server, and the server will handle that incoming request, maybe store some order data in a database, and once it's done, it will reply back with a new response, with a new web page, a new HTML document which is sent back to the client, maybe the order confirmation page. So this is how we interact with the web. This is how web pages traditionally work. Now, JavaScript helps us make this more reactive. It helps us make a web page more reactive and skip that second request response flow in some circumstances to instead change the already loaded page and do something there. Now let's simply see an example which should make this clearer. For that, attached you find a simple project which has 3 folders or 2 folders and 1 file. An assets folder, an info folder, and an index.html file. The extra folders and files you see here are just here in my local setup for version control and for my editor settings. And we can ignore them right now. You don't need them. They're not related to the web page. So we got 3 things in there, 2 folders and the index.html file. Now you can simply double click that index.html file and it will open up here in a new browser window, or it should at least. If not, open a browser window and drag the index.html file into it. Now this is a little dummy page I prepared for you. It holds some dummy information about this course and about me, your instructor. All this information is valid, by the way, but of course we're not building this web page here. Right now this is mostly HTML and CSS, or to be precise, it's pretty much all HTML and CSS at this point. And you can always go back to these files, and in the assets folder you'll find an images folder with my image, you'll find a styles folder with the CSS files. And if you would look into the index.html file, for example, by right-clicking on it and opening it with a text editor, and you can use either a text edit here on Mac or the normal Notepad or text editor on Windows. If you are using text edit on Mac, go to Preferences here, and on Open and Save, make sure you check this Display HTML files as HTML code instead of formatted text box. Then close this and reopen with text edit, and this only applies to Mac here, and you will see the raw HTML code. So this is a bunch of HTML code here, but what you won't see in there is anything JavaScripty in this file. It's just HTML and some imported CSS styles. This leads to this page, and here on this page, we have these two links, dynamic interpreted and weakly typed. And if you click on any of these links, you're taken to a new page. Here's the dynamic page, where we see a more detailed explanation, and here's the weakly typed page. Now what we have here is a traditional web page, and what we also have here is a new request being sent to a server if this were served by a server instead of our local file system, and a new page being loaded, right? We're always loading a new page here. Now, of course, there's nothing wrong with that, but a more modern way, a more user-friendly way of doing that might be to not load a new page here, but instead to show this piece of information maybe in an overlay to the existing page, such a modal as it's called, a little pop-up like window which gets loaded as an overlay on this already existing page, so that we don't need to fetch a new HTML page and break the user experience a bit therefore, but instead that we stay on this existing page and only tweak it a little bit. So we kind of need to tweak the existing HTML code, this code here, which was loaded by the browser, whilst we are on the page, so without loading a new HTML file. That's the idea, and that is where JavaScript can help us and why JavaScript was invented and why it is so important these days. Because any modern website you visit, all these exciting user interactions you have there, with drop-downs, with overlays, and so on, all of that is driven by JavaScript. And we can turn this page here into a more exciting page as well. I prepared something for you. You might have noticed that in this starting code I provided to you, in the assets folder, you also have a scripts folder with an app.js file. .js stands for JavaScript, and this is how you store JavaScript code in JavaScript. Now we can of course also inspect that file by clicking on Open With, and then also text edit. And what you see in there is JavaScript code. Now at this point of time, of course, you won't understand all this code. Maybe you understand none of that if you have no previous experience with JavaScript, and will of course change that throughout the course. We'll start at the core basics, and you will understand all this code once we progress throughout the course, and of course once we completed the course. But for now we can just take this code for granted, close this file, and ignore it. And instead let's go back to our index.html file, to the source code we opened here in the editor. And below this link here, where we import the app CSS file, above the head here, let's add a new HTML tag. Script, also a closing tag for it. And then add a src attribute to script here, and point at assets/scripts/app.js. So at this JavaScript file we just had a look at. That alone won't do the trick. Let's also scroll down a bit and go to these two links we have here, to the dynamic interpreted and the weakly typed link. Now there, let's remove that link to info dynamic HTML and add a hash instead, and instead add a new attribute here, data-text, to this anchor tag here, equals, and then double quotes. And now let's go to the info folder and then to the dynamic HTML file, open that with the text editor, and simply grab the text you have in there between the paragraph tags, excluding the paragraph tags, and copy that and paste that here between the double quotes. Now make sure you get rid of any line breaks you might have in there, because that will not work, so that this is all one long line of code in the end. And thereafter add one more thing to the anchor tag, class, to add a CSS class, info-modal. Now repeat that, We can copy all of these attributes on the second link and replace its reference with the hashtag reference as well. And the text we show there should of course now be the text we find in the weakly typed HTML file. So if we open that with the text editor, let's grab this text here we find in there, copy it, and also replace the text here on the second anchor tag with this text. Now, again, make sure you get rid of any line breaks you might have here, because these will break your code. Now with that, let's go back up to our script import and add one important word here after the src attribute, and that's the defer attribute. This controls how and when this JavaScript code is executed, and I'll dive back into this a little bit later. For now, let's just add it. Then save this whole index.html file, go back to your page and reload it by simply clicking the reload icon here, and then click on one of these links. And now you will get this nice overlay here, which you can also close by clicking on that backdrop. Now what we have here is new content, which is dynamically added to this existing web page by JavaScript. We're not loading a new web page here. Instead, this overlay is shown by JavaScript. And this, of course, is a way better user experience, because now we don't send the user off to a new page. We don't wait for new HTML code to be downloaded. We change the existing page. And this is something you see on a lot of modern web pages because it's faster. It's more like in a mobile app where you also don't have to wait for things to complete. And therefore, this is one of the core reasons why JavaScript is that important. It allows us to make web pages more dynamic. So if we come back to that question of what JavaScript is, if I quickly dive into the core things we learned on this previous slide, JavaScript is a dynamic, weakly typed programming language. It's an interpreted language, which means it's compiled on the fly. It's compiled before it runs and not compiled during development as some other programming languages are. It's a hosted language that runs in different environments, though thus far in the last example we just saw it run in the browser, but I'll come back to other environments in this course as well. And the most prominent use case is the case we just saw. We run code in a browser on a web page to make that more dynamic. So now we understand why we use JavaScript and what it allows us to do. But what do these terms, dynamic, weakly typed, and interpreted, as well as hosted language, mean in detail? Let's have a look at this interpreted, on-the-fly compiled thing. How is the JavaScript code in our browser executed? And not just in our browser, but typically in any environment where you run JavaScript. Let's say you write your JavaScript code and you want it to have some effect on the web page if we talk about the browser as the environment where we run our script. Then you have one important thing built into any environment where you want to run JavaScript code, and that's a JavaScript engine. It's built into the browser, as I said. There in Chrome, for example, in the Chrome browser, it's V8, that's the name of the engine. In Firefox, the name would be SpiderMonkey. And of course, other browsers also either reuse these engines or have their own engines. Now, the job of the engine is to parse code, so parse, read, and understand your JavaScript code. Then, on the fly, compile it to machine code, because machine code executes faster. So it reads your code, but it does not necessarily execute it like that, but instead it now takes that code and compiles it to code, which is faster to execute by the machine, and then it executes that machine code. This all happens in the browser with the help of the JavaScript engine. And then when that code is executed, we have that effect on our web page. Now, important modern engines have a lot of optimizations there. They might start executing your uncompiled code and then compile the code whilst they're also already executing it to get started executing faster, and then switch to the compiled code dynamically and so on. So we have a lot of optimizations going on here, and we will dig a bit deeper into what the JavaScript engine is exactly in a separate module in the course. For now, this is all we need to know. The browser has a built-in tool that takes our code, compiles it, optimizes it, and executes it. And also a bit more technical side note, all of that happens on a single thread. Now, this is very technical, but you might know that In a computer, you have certain tasks that are executed. For example, the browser you opened is a task, or actually it might consist of multiple different tasks that are executed together. The JavaScript code is also yet another task which your operating system in the end has to take care of. And this runs on a single thread. Of course, we have multi-threading on modern machines so that they can do multiple tasks at the same time, but the JavaScript code execution runs on one single thread there. So the JavaScript code execution always happens in one single thread on your operating system. Right now, this doesn't really matter. It will become more important later in the course, though, when I will come back to this concept of single threading and which implications this has for JavaScript. But with that, we know what interpreted means, what compilation means, and how the JavaScript code is executed. What does dynamic and weakly typed mean then? JavaScript is a dynamic, interpreted programming language, but it's also a weakly typed programming language. Now, what does this mean? For one, the dynamic interpreted part, as you learned, means that it's not pre-compiled. Other languages, like C++, are compiled during or after development, so before you share them with the end users. JavaScript is on-the-fly compiled. And that means that the code is evaluated and executed at runtime. It also means that the code can change at runtime. Now, of course, not the code you wrote, it won't magically change. Of course, the code you wrote gets executed. But in that code, you can do some things which you're not allowed to do in other programming languages. For example, if you're working with a variable, something we will only learn in the second module, for now you can just keep in mind that a variable is a data container. You might store, let's say, some text in there. Text you need in your script to, for example, output it to the user. In JavaScript, you are allowed to dynamically switch the type of data there. In a variable, you might start by storing some text, and suddenly at a later point of time, you store a number in there instead, in the same variable. Now again, we haven't really learned about variables yet. We will, of course, do that. But the one thing you can simply keep in mind is that the dynamic thing in JavaScript means that it is parsed and interpreted and compiled at runtime, and that therefore it is able to do certain things. For example, switching the data of a variable other programming languages are not allowed to do. Now, it's not necessarily good to switch the type of data dynamically or unexpectedly, but you can do that. The main takeaway, however, is the on-the-fly compilation and interpretation. Now, what about the weakly typed part here? This means that when we work with data in JavaScript, for example, text data or numbers, you don't have to tell JavaScript that you're going to work with a text now or you're going to work with a number now. Instead, data types are assumed, are inferred automatically, so to say. That's also related to this dynamic nature where data types can also change from one line to another. Now, this might sound strange, but in other programming languages, you have to define the type of data a variable will hold in advance. In JavaScript, that's not the case. You don't have to tell JavaScript that this variable, this data container, will hold a number. Instead, you store a data in there, and if that happens to be a number, so it is. In other programming languages, you have to tell the language that you're going to store a number in there, and if you store something else, you would get an error. That's not the case in JavaScript. It's forgiving there because it's dynamic, and it also doesn't care about strong type definitions in advance. Instead, you just store data in there and go with whatever type of data that holds. So data types are not set in stone, but can change. Now, this is arguably a bit more advanced. I just want you to be aware of these terms, dynamic and weakly typed right now, and they will make more and more sense as we progress throughout this course and work with data and variables. For now, just be aware of these terms. Now, the last thing we saw on the previous definition slide is that JavaScript runs on a host environment. So that means a JavaScript engine can be part or can be executed in different environments. The most well-known environment is the browser. Modern browsers have JavaScript engines built in, and they're therefore capable of executing JavaScript code. But you also can run JavaScript in other environments, for example, on the server side. So write on a computer without having a browser in between. So not inside of a browser, but simply execute code like this on your machine. Now, JavaScript was invented to run in the browser to make websites more dynamic, to be able to change things on a website without loading a new page, you could say. Because JavaScript is able to closely work together with the loaded HTML code, with CSS. You can also use JavaScript to send background HTTP requests, so to send some behind-the-scenes requests and fetch data without reloading the page, and much, much more. And we'll do all of that throughout the course. Now, there also are certain things JavaScript can't do when it runs in the browser environment, though. For example, it can't access your local file system for security reasons, because otherwise every web page you visit would be able to read your file system, maybe delete files on your computer, and so on, which would be horrible, of course. And in general, it is running in a sandbox, you can say. It's not able to interact with your operating system and so on. The browser gives you certain things you can do in this environment and doesn't allow other things. Now, as I said, the browser is only one environment, though, the one for which JavaScript was invented, but not the only one we're restricted to right now. Instead, the JavaScript engine Google developed, V8 is the name of the engine, was extracted by some people to run JavaScript anywhere. Because the idea was, well, if we have the engine in the browser, why don't we take it out of the browser and then make it available as a standalone tool which you can use to execute JavaScript anywhere else directly on your machine. And this tool is in the end called Node.js. Now, in this course, I'll have a separate module about Node.js where I show you how that works and how it uses the same JavaScript syntax you learn throughout the course, but which new features it brings to the table. For the majority of the course, however, we'll focus on the browser side, because this is the side where you absolutely need JavaScript, and it's also the side where you're able to see more because you have a web page where things change and so on. Now, back to Node.js though for a second. Node.js can be executed on any machine, and therefore it's also often used to build web backends, to build web servers. Server-side JavaScript is also something you often hear as a description for that. Now, you might know about server-side languages like PHP, or also Java and other languages as well. Well, JavaScript with Node.js can also be used to run it on the backend of a web page, so on the server and not on the client in the browser of your users. Now, Node.js also has certain things it can do and can't do. Since it runs directly on a machine, in Node.js you're able to access the local file system, so you are able to write files and so on, because unlike browser-side JavaScript, Node.js code has to be executed actively by you. It's not like you visit a web page and then this starts happening. Instead, it can only access the file system on the machine where it executes, which, for example, is the server where it runs, not your machine. And it's also able to interact with the operating system and so on. However, on the other hand, since it doesn't have direct access to the loaded web page, it can't manipulate HTML or CSS like browser-side JavaScript is able to do. So we basically have inverse access capabilities here. And these are the different environments where JavaScript is able to run. Now, in this course, we'll focus on the browser side because the JavaScript syntax you learn will be the same no matter in which environment you run JavaScript code. But in the browser, we simply have more visual feedback and can see what happens. Nonetheless, as I said, we have this separate Node.js module later in the course where I'll also dive into the different things we can do in Node.js and how that works. So we saw some JavaScript in action. We have the basic definition out of the way and hopefully now have a basic understanding of what JavaScript is and what this language is all about. Now, what's in this course though? What will you learn in this course? You could split this course into 3 main blocks, I would say. The core basics, which you have to know under all circumstances. Then the next block where we build up on these basics and build a really strong foundation. You could therefore still call that basics, but these would be the advanced basics. And then we have advanced concepts, which allow you to get to the next level of JavaScript development and become a really good JavaScript developer. Now in the core basics block, we get started. This is this module. We learn the core basics about JavaScript and its history and so on. But once we're finished with this module, we'll dive into all the core syntax, the language basics, into variables, functions, what all of that is. All these core things that make up the JavaScript language, which you have to know no matter in which environment you want to execute JavaScript. We'll dive into efficient development and debugging, how to configure your environment correctly, how to fix errors and how to find them. We'll dive into control structures, if statements, loops, so that you can execute code multiple times based on some conditions. We'll look behind the scenes of JavaScript. We'll see what the JavaScript engine does in detail. We'll have a closer look at functions, a very important concept as it will turn out. We'll have a look at DOM basics. DOM stands for Document Object Model, and this will all be about manipulating the web page we're running on, adding content, removing content, and so on. We'll have a look at arrays and iterables, so at lists of data and how we can work with those. We'll have a look at objects, which are super important data structures in JavaScript. And once we're done with that, you will have a solid basic understanding of the JavaScript core syntax and the core features. Now thereafter we'll build a stronger foundation, and if you already know all the core-based syntax, this of course might be a great entry point. You'll find a module in the curriculum, if you check that, about classes and object-oriented programming, which takes object usage, you learned about objects in the core basics, to the next level. You'll learn about constructor functions and prototypes, important core concepts baked into the JavaScript language. We'll dive deeper into the DOM and how to work with the browser and tap into certain browser features. We'll dive deeper into events, how we can react to mouse clicks, and so on. We'll have a look at functions again. We'll dive really deep into functions and learn about things like recursion and more advanced function usage. We'll explore the number and string types in greater detail and which restrictions we have there and what we can do there. We'll dive into asynchronous code, which will be related to that single threading I mentioned, and how we can run longer taking operations without freezing our web page. We'll dive into these background HTTP requests, also sometimes referred to as AJAX, which I mentioned earlier, which allow us to exchange data behind the scenes without reloading the page. And once we did all of that, we will have a very solid foundation, not just the basic core syntax, but we'll also know all the important parts of the JavaScript language and of using JavaScript in the browser. Now, of course, then we'll also dive into more advanced concepts. You will learn how to work with third-party libraries, how to utilize JavaScript modules and split your code efficiently across multiple files. We'll dive into tooling, which allows us to optimize our JavaScript code, namely Webpack and Babel. We'll briefly dive into browser storage and how you can store data in the browser. We'll have a look at browser support and how you can ensure that your scripts run in all browsers where they need to run, no matter which browsers your end users are going to use. We'll have a look at JavaScript frameworks, and there we'll have a look at the React.js library. We'll have a look at meta programming, how you can write code which is easier to use by other developers, really advanced but really important. We'll have a look at Node.js and see how that differs from browser-side JavaScript and what will be the same. We'll have a look at security and how you secure your code and which security holes you want to avoid. We'll of course also see how you get your code from your local machine onto a server where other users can use it. We'll have a look at performance optimizations and fixing memory leaks to ship the best possible code, and much, much more. This course is a big course. It has a lot of hours of content because it's simply packed with content. You can simply go from lecture 1 to the last lecture, or of course also dive into the modules which are most interesting to you. I did my best to build the course in a way that allows you to also use it as a reference, so that you don't always have to restart at the beginning if you are coming back to it after a year or so, but that you can dive into the sections which are most interesting to you. Though if you are new or relatively new to JavaScript, my strong recommendation is that you start with Lecture 1 and Section 1 and you go through the course step by step, maybe just speeding up playback if I'm going through some concepts you already know. So this is what's in the course and how you can take it. I also want to make sure that you get the most out of this course though. And for that, of course, you should watch the videos. Watch them at your speed, use the playback controls, the speed controls in the video player to speed me up if I'm going too slow for your taste in a certain video or on a certain concept, but also slow me down if you need more time. Also pause and rewind if a certain concept is not clear yet. It's a video on demand course, so take advantage of that. You can watch a video more than once. This is absolutely fine. Also, code along. Pause and rewind, as I said, if I'm going too fast, and also pause regularly to try implementing what I'm about to implement on your own first. This is the best way of practicing. I also got tons of quizzes in this course which you can use, because practicing, of course, is important. So do the assignments you find, follow along in the practice projects we dive into, and do the quizzes to check your knowledge and make sure that we're all on the same page. Also, of course, if you're facing errors, if something does not work as expected, use the knowledge you gain in the development and debugging section and debug your code. Search for errors and also search for solutions. You can use the attached code snippets, which you find attached to multiple lectures per module and always to the last lecture of each module, to compare your code to mine. If something is not working as shown in the video, chances are that there is a difference in code, and comparing code is what you should do in that case to find and fix the error. You can also replace your code step by step with mine temporarily to narrow down the issue. But also Google error messages if you find them, and use the search built into the Udemy course player. That allows you to also find many common issues and fix them on your own. But of course, if you're stuck or if some concept is unclear and you're not able to proceed on your own, also ask and answer. You have a Q&A section in this course, and there you can ask questions, and I will read and reply there regularly. But also use it to help others, because you will learn the most if you don't just ask, but if you solve problems on your own and if you also help others solve problems. Because that forces you to think about an issue and find a solution, and that ultimately is always how you learn the most. So now, before we dive into the next module, where we dive right into the language, let me dive a bit deeper into the history of JavaScript and where it's coming from. And there, let's also have a look at that comparison between JavaScript and Java again. Now, Java and JavaScript are two totally independent programming languages. That's really important. They have a totally different syntax, different principles. They have almost nothing in common besides the name, I would say. Also, JavaScript runs in the browser, and as you learned, also in other environments. Java does not run in the browser. You can use it on the server side to render HTML dynamically there and send it back to users. You can also use it in a non-web development context, but it is not supported directly in the browser. You can't use it for the same things as you can use JavaScript. You also, as I mentioned, have different principles. Java, for example, is strictly object-oriented and strongly typed. There, you need to define which kind of data you're about to store in a data container. Whereas JavaScript is really flexible. You don't have to work with objects only there, and we'll dive into object orientation and what that means throughout the course, no worries. And it's also weakly typed, as you learn. Now, JavaScript was named JavaScript to sound cool, you could say, because Java was a big thing, and JavaScript kind of was inspired by it, but is totally different then in the end. And, well, people just wanted to have other people use JavaScript, I guess. Java does not run the browser, as I mentioned, though. That's really important to keep in mind. JavaScript does. And speaking about that differentiation between client-side and server-side JavaScript, Client-side means in the browser, server-side with the help of Node.js means on a machine that is connected to the internet, which might be serving web pages, but which doesn't run code directly on the machines of the end users. And the client-side part is really the origin of JavaScript. And as you learn, different browser vendors, so different companies developing browsers, provide their own JavaScript execution engines. For example, the V8 engine, that's the name of the JavaScript engine Chrome uses. And the important thing there is that in the browser, you are able to interact with the web page from inside JavaScript. You can manipulate the loaded web page. You can also use certain browser features, so-called APIs, for example, to get the user location. On the server side, the idea was to, well, extract the engine out of the browser and allow you to run it outside of the browser so that you can reuse your JavaScript knowledge, but now use JavaScript for different tasks. And you can now run JavaScript anywhere with Node.js, for example, on a server side. And there you have special other features, other APIs you can tap in, for example, to work with the file system or handle incoming HTTP requests. Now, the syntax, concepts, and core features are exactly the same though. Therefore, what you learn in this course, where we primarily focus on the browser side, since it's simply also easier and more visual to use, are the same. What you learn in the browser applies to Node.js and other environments as well, as you will also see in the Node.js section. So that's why we start with the browser side. It's JavaScript's origin. There are no alternatives to JavaScript in the browser, so you might not be interested in using JavaScript on a server. If you are interested in front-end, in browser-side web development though, you have to learn JavaScript because that is the only programming language you can use there in the end. You can then transfer your knowledge because Node.js uses the same syntax, so you easily learn Node.js after learning JavaScript in general or in the browser. And it's more fun to learn JavaScript if you see something on the page. So now that we know what JavaScript is and where it runs, let's have a very brief overview of the JavaScript history so that you know how it evolved over time. In 1995, Netscape introduces LiveScript, which thereafter was renamed to JavaScript. Now, in 1996, Microsoft also released its own version of JavaScript in Internet Explorer. So same idea, generally same syntax, but also differences. So we already had an issue there. Back then, JavaScript also wasn't able to do a lot of things. It was mainly used for spammy things, for annoying overlays and pop-ups. But another problem was that you had to write very different scripts for different browsers. In late 1996, people saw that this fragmentation could be a problem, and therefore JavaScript, the language, was submitted to the ECMA committee to start standardization. This simply is an organization which was then responsible for standardizing JavaScript so that you have one standard which then could be implemented by multiple browsers. So then we had ongoing standardization efforts until 2005 roughly. And Microsoft didn't really join the party. Well, we know how Microsoft was in the late 90s, early 2000s. Ultimately, they supported the standardized JavaScript version. Still, there were differences, but we had a more common way of using JavaScript. Now, the efforts of standardization continued, and we had huge progress until 2011, I'd say. And Microsoft eventually joined forces and became part of the standardization process and of contributing to building that standard and adding new features. Because that's important. My timeline ends here. The development of JavaScript absolutely does not. I would say, especially since 2010-11, it really picked up. And it is under active development. It's evolving, new features are getting added, it's getting a better and better programming language. And whilst it was quite clunky around 2006 and 2007, and despite standardization, every browser still did its own thing in some regards, we nowadays really have a uniform language with some small differences, but mainly one core language we can use in different browsers. Still, different browsers have their own features you can then use, but the core language is the same. And in the browser support module later in the course, I'll explain how you find out which differences we still have and how you work around them. But in the end, we now have a standardized language which is really great to use. And we have that thanks to this ECMA international organization. Now, this organization in the end manages a language called ECMAScript. But ECMAScript and JavaScript actually have a strong relation. ECMAScript is the actual language which is evolved by the ECMA International Organization, but ECMAScript is then implemented as JavaScript by browser vendors, so by the companies working on the browsers. So it is the most famous ECMAScript implementation. JavaScript is that most famous ECMAScript implementation. Others would be ActionScript or JScript, and you don't really need to know those. So JavaScript in the end is ECMAScript, we could say, and we have that organization that evolves ECMAScript, and with every new standard version, you could say, which is in the end then created and finalized, browser vendors take that and implement it into browsers. So ECMAScript itself isn't directly used, but browser vendors implement it into their JavaScript engines. Each browser comes with its own JavaScript engine though, and therefore it's each browser and the engine used by the browser which defines which exact features are supported. And actually browsers also sometimes implement certain features at an earlier point of time than they're really finalized in ECMAScript. So whilst discussions might still be going on over final implementation details, browser vendors could already go ahead and implement a certain feature in their engine already, so that you can already use next generation JavaScript code earlier in one browser than in the other. And that's also something I'll come back to in the browser support module, where you will learn how to use next-gen JavaScript when writing your code and still ensuring that it runs in all browsers. So ECMAScript is under active development, and browser vendors are contributing there as well, are shaping how JavaScript looks like and which new features we want there. And therefore JavaScript is under active development, and therefore it's an always evolving language. Now in this course you will learn JavaScript in the most modern way you can, using all the latest modern syntax. And this is important because in 2015, 2016, JavaScript saw a major overhaul, a brand new version, you could almost say, with a lot of important changes. And many tutorials and courses actually teach you the old JavaScript syntax, which still works, but which is not the most recent one, and which has certain downsides. And then they later switch to the modern syntax. In this course, you will learn the most modern syntax right from the start. I will also show you the older one, because you will still see it in other tutorials and code snippets, and you should be able to understand those. But we start with the modern one, and we stick to the modern one. So you learn all the latest JavaScript in this course. Now, hopefully, you're now excited to get started, and so am I. Before we get started, we just have to make sure that we have a proper development environment. So a good environment where we can write code and dive into JavaScript. Because writing code in a system text editor, as we did it earlier in this module, is really too cumbersome, not really a great experience. If we have a look at that, well, this is really hard to read. And if we write a lot of code there, that's not fun at all. So we need a better code editor, which makes working on our code easier, which takes some work off us, and makes it more pleasant in general. And we also need an environment where we can test our web page and our code. Now for the editor, I strongly recommend using Visual Studio Code. This is not the only code editor or IDE for integrated development environment which you can use, but it is free and it's really great. It's super fast, very modern, under active development, really extensible and customizable. It's my strong recommendation to use Visual Studio Code, and we'll install it together in just a second. You can combine it with a lot of extensions, which you can install from inside Visual Studio Code, and you can configure it to suit your needs. And I have a module where we'll dive deeper into that, but I'll also show you a basic setup, which I use right in this lecture. Now for testing and seeing our code in action, we also need a browser, and there I recommend using Google Chrome. Of course, we will write code that runs in all browsers we want to support. More on that in the browser support module. But for development, Chrome is really amazing. It has a lot of features that make development easier, and my strong recommendation therefore is to use Chrome for development, even if you normally use a different browser. Really use Chrome to have the same result as I do here and to follow along smoothly. Again, later you will learn how to make sure that the code runs in all browsers where it needs to run. Now, in Chrome, we will also use the developer tools which are built into Chrome to have a look at our code, debug it, and so on. And I'll also have a look at that in the development and debugging section later in the course. But with that, let's get started with the code editor, with the IDE, with Visual Studio Code. For that, you can simply Google for Visual Studio Code, and you should find this page, code.visualstudio.com. There you can learn more about this code editor, and you can always check out the docs if you're interested in diving deeper. And of course, you can also download an installer. Here, it should already pick the right one for your operating system. Otherwise, choose one from the dropdown. Visual Studio Code is available for Mac, for Windows, and for Linux. Simply download the installer from this page, where you then also see some getting started instructions, and run through the installation process once you did so. It's a straightforward installation process, nothing fancy about that. You can just go through the downloaded installer and install Visual Studio Code on your system. Once you did that, you can open the editor, and it should look something like this. Now, if it doesn't have this dark mode look here, you can change the theme by going to your options here, Preferences, and then Color Theme, or using the shortcuts you see there. Under Windows, you will find the preferences under File. When you choose Color Theme, you can pick a theme, and you see a bunch of themes available. You can simply cycle through these themes with the arrow keys and check out which theme you want to use. Now, I like this Dark Plus theme, but of course you can go with the theme you like. You also see a bunch of elements here at the start. You can also customize this under View, Appearance, and there, for example, you could get rid of that status bar at the bottom if you wanted to. Now, I will add it back, but you can tweak this to your likings to make sure that you see the information you want to see. Now, as you see, we don't see our code here, so we can click Open Folder here, or choose File, Open, and then choose the folder you do want to open. And here, I chose the folder with the starting code we saw earlier in this course. You find it attached to this lecture again. Simply open the whole folder, and now this will load this project into Visual Studio Code here. Now, the colors of these files might look different. That has something to do with version control, something we don't have to worry about right now. But you should see these files and folders here. Again, you won't see the gitignore and VS Code file here. These are folders and files only I have here for my configuration. You should see the assets, info, and index.html folders and file though. Now, what might also be different for you, however, is the icons you see here. Now, that's coming from a so-called extension I added. Extensions are plugins you can add into your editor to change it and tweak it to your likings. You can add plugins and extensions by going here to this extensions part. You can also get there by clicking on View, Extensions, and that's actually how I will navigate, and I will remove that activity bar here on the left and just navigate around with View, and then here these shortcuts or these options, and now we're on the extensions part. Now, I already got a bunch of extensions installed. Most of them are not required here for this development, but there are some which I do recommend using. And one is the Material Icon extension. You can just search for Material Icon, and you should find the Material Icon theme package. Now, this is totally optional, but you can install it. You will have an install button here to get the same file icons as I do. So you can install it and then load the extension with the buttons you see here to add the same icons. Another extension I recommend using is Prettier. You can search for Prettier, written like this, and install and enable this extension. This is an extension which helps us with code formatting. Now, code formatting allows us to write clean and well-readable code. Because as you will see, a lot of code is valid from a technical perspective, but can be hard to read. I'll show you an example in a second. With that, we have all the core extensions I would recommend here. You don't need the other extensions I have here. They're not even related to JavaScript development necessarily. And therefore, we should be good here. You can now go back to the Explorer view here to see your files again. And now let me show you how you should basically configure your project and what this code formatting is all about. For that, let's open the assets folder, scripts, and their app.js. And there you see the script I'm giving to you. Now, you already see here why we're using a code editor. This, and all's in the HTML file, is much more readable than this here, right? It's much more readable. Keywords are highlighted. We also get information if we hover over something. We get useful auto-completion if we type, and so on. And you'll see all of that throughout this course as we write code. You don't need to understand this code here, of course. We will learn all about that throughout this course. But I want to show you this auto-formatting. Let's say here in line 6, I don't have this white space at the beginning, or I even have code like that. Technically, this is valid code. I can already tell you that. JavaScript is able to understand and execute this code. But to us humans, it's a bit harder to read. And that's where we can use so-called auto-formatting. If you go to Code, Preferences, Keyboard Shortcuts, and there you search for Format Document, you will find this shortcut with a certain shortcut attached to it. If you don't have one here, you can right-click on this and change the key binding to assign a shortcut. And this is a shortcut you can then press to auto-format your code. You saw that? The code magically changed to a more readable version. This is something where Prettier helps us. Now, in general, of course, you can tweak your keyboard shortcuts here, not just the format document, but any shortcut you might be using here in these settings. You got a lot of shortcuts you can use. Of course, you can use the official documentation to learn all about Visual Code already if you want to. I will also share some useful hints with you in the development and debugging section later in the course. One thing which I would recommend that you do is that you also dive into Preferences settings right now, though. And there you can switch between user and workspace settings. Basically, user settings are settings that apply to all projects you manage with Visual Studio Code. Workspace settings only apply to this project. For example, here I got a workspace setting, and that's where this .vs code folder is coming from, where I set the zoom level to 6 so that this is more readable to you. That's all I have in there. Now, under Preferences settings, you can tweak your user or your project-specific settings. And there, for example, you can search for Prettier and configure Prettier here, as you see, and the various options it offers you to format the code as you want. For example, some things I have set up there is that I want to add semicolons at the end of every line. I have this checked. I have single quote checked to use single quotes for text. And I have a tab width of 2. Now, this is not something you have to do. These are just my settings in case you want to have the same code output as I have it here. And with that, we have a basic editor setup, which we can use to write our code throughout this course. Now, let's come back to the browser. As I said, I recommend that you use Chrome there, and you might want to use incognito mode to avoid any distractions by any Chrome extensions you might have installed, which might interfere with your web page and maybe do something which is not caused by your code, but by some extension. Also important in Chrome are the developer tools. You can get there by using View, Developer Tools, or the shortcut which is shown there. And these are the developer tools we'll also spend a lot of time in. I'll zoom in a bit here to make it a bit bigger. And there, for example, we have this console where we can output some development log messages, something we'll do throughout the course. We have the Elements tab where we can see the rendered HTML content, and so on. Now, one important setting I want you to make here in the developer tools to also have the same output and behavior here as I have it. In the console area, if you click on the gear icon here, make sure preserve log is not checked. This simply makes sure that whenever you reload the page, this log will be emptied and we see a new log output for the currently running page. Now, that's all. Now, we'll have a closer look at the developer tools in a separate module. I just already want you to be aware of them, and I want you to make sure that you use Chrome and have a properly set up editor. And with that, we're all set. We can now dive into JavaScript, its basics, and get started learning this amazing language. So let's dive right into JavaScript, into its core syntax and some core features which you'll need in any JavaScript program you're going to write. Specifically, in this course module, we'll have a look at the core syntax, so how you write valid JavaScript code. We'll explore variables and understand what we use them for, how we create them, how we use them in our program, and with which kind of data we can work in our program. We'll have a look at operators, so how we can actually run calculations and execute some code by combining values and by doing something useful. And we'll also explore and use functions, an important language construct, which you'll find in actually pretty much any programming language you can work with, and therefore it's also part of JavaScript. And here we'll have a look at what functions are, why we use them, and how we use them. And we'll do all of that, all these things, in the context of a basic application we're working on, where we can also see something on the screen and where we see these things come together in a real-life example. Now for that, we need a basic website where we can use JavaScript. And I'm using a website here, and I'm not running JavaScript on the server, as I also mentioned in the first course module, because I find it more interesting to learn JavaScript if you can see something visual on the screen. And a website is something visual, which is why we'll use that. Now for that, for this basic website, attached you'll find a starting project, a starting code, which you should download and extract and then pull into a folder which you then open with your favorite IDE or code editor. In my case, I'm using Visual Studio Code, which is the tool I explained in the first course module, set up as explained there. So I'm just using that setup and the tool I explained in the first course module. So open the extracted attachment with that tool here by going to File, Open. And you should then find a folder structure that looks like this. Now, one important note, the .vs Code folder might not be there in your setup. This is just a folder created by my IDE, by Visual Studio Code, to manage some settings. In this case, the zoom level, which I set so that you can clearly see all the code I write. So that's not something you have typically. And git ignore, I have this because I'm also working with Git, which is a source control management system. And you don't need to use that. You don't even need to know what that is to follow along. It has nothing to do with JavaScript. After this lecture, you find a basic introduction to it, but you can also skip this for now and come back to it later. It's not required, not directly related to JavaScript. So what you should have in here is this index.html file with a basic HTML skeleton, nothing too fancy in there. I'm pulling in some fonts, linking to the style sheet, which you find in the assets folder in the styles subfolder. And then we have this basic skeleton down there. And in the script section, you find one starting script. You can look into it, and there's a bunch of code which probably won't tell you much, which I provide to you because this script actually includes some features which we don't really know yet, which we also won't fully understand by the end of this module, which is why I provided instead of writing it together with you, but which we'll of course be able to understand later in the course. But we need that to get something out on the screen and see something on the screen and not just have a boring application where nothing changes. Hence, I provide this to you. For the moment, you can just ignore this, take it for granted, and this will all make sense a bit more by the end of this module, and ultimately way more later down into the course. But of course, we'll learn more than just that. This is just some starting script which we need. So that's what we got. Now you can double click that file here, not in the IDE though, but instead in your normal Windows Explorer or Mac Finder. So there, simply double click that index.html file, and it will open up a brand new window in the browser, which should actually yield this interface. Now, this is a basic calculator, which will work a bit different than most calculators you're used to, but nonetheless, which we'll work on throughout this module. Now, for the moment, you can type and hit what enter you want. Nothing happens here because we'll write this logic together, and by writing this logic, or whilst writing it, we'll dive into the basic JavaScript features. So that is what we'll build, this calculator here. And now to build it, let's start writing some JavaScript code, because we need some logic that runs here with that page being loaded in the background, so to say, to interact when the user presses one of the buttons and to update the result, which we see down there and so on. And that's what we need JavaScript for, because with just HTML and CSS, we can't add this in the browser dynamic logic. As you learned in the first course module, you need JavaScript for dynamic features or for dynamic actions like this, and that's exactly what we'll dive into in this module, therefore. So we want to write some script code, and as I mentioned already, you got the vendor.js file, which you could name however you want. I just named it like this to make it clear that I provide this to you and you don't really need to care about it. So we could add our code in that file, but actually we won't. And instead I'll create a separate brand new file next to it, which I'll name app.js. Now you can also name this file however you want. I'll name it app.js because it will drive our simple front-end browser-based application we're building here, but you could name it my-script.js or just script.js or whatever you want. The only thing that matters here is the file extension, which should of course be .js because it will hold JavaScript code. Now that's the script file we'll work on, and that's the file where we will add our calculator logic. Now to get started and see that this works, let's start very simple and simply add in an alert where we say this works. Now, you might not fully understand what's happening here, what this alert thing means, what these parentheses mean, what these single quotes here mean, and we'll explore all of that throughout this module, but just enter this for the moment and then go back to your page and reload. And what you'll see is that nothing happens. Well, the reason for that is that, of course, I added my script file here, but the default behavior of the browser is not to scan all subfolders next to my HTML file, which I loaded, for scripts which it could execute. That would be a horrible default behavior because it would mean that we can't control when which of our scripts runs, and we want to control that. So of course it's good that the browser doesn't load and execute our script by default. But how can we tell the browser that it should load and execute that script? There are a couple of ways of importing JavaScript. Now, the first way of importing it is to go to the HTML file, and in there, like here, in the head section, let's say, you can add a script opening and closing tag, and you can add JavaScript between those script tags. So we could write alert, this works, between script tags, in here. So the alert function, just as I used it here in app.js, but not in app.js, but between the script tags here. If we do that and I reload this page, you see, before the page loads, I already see that alert indeed, and I can click OK and confirm this, and now the rest of the page loads. Now that's one way of doing it. Now you can, of course, throw in some script code here into your HTML file, but the downside with that is that the longer your script gets, the longer this HTML file gets. And this is not necessarily a technical issue, but one issue it might be is that for you it gets harder to manage your website. If all your script and all your HTML is in one file, then this file gets very big. And if you then ever need to change something in there, be that JavaScript or be that HTML, you need to scroll through all the content here and find the part you want to change. So putting your scripts in there is typically not the best idea unless it's a very, very, very short script. Instead, you typically want to import your script. And therefore, you add a source attribute, src, to the script tags, and then between double quotes, typically, single quotes or no quotes at all would also work to some extent, but typically use double quotes, you point at the location of your script file. So in my case here, I point at the assets folder by adding assets, then a slash to kind of go into that folder or to tell the browser to look into that folder. And then there we want to go into the scripts folder, right, which is a folder we have in there, and then go into that folder and then load the app.js file. That's what we want to tell the browser. It should go in there and load the app.js file. Now important, you still need a closing script tag here. You must not have a self-closing script tag like you have it for the link. That's not supported for script tags. You must have an opening and closing separate script tag. And now with that, indeed, you should see that when I reload the page again, we see just this works from this file. So if I go back and I reload this page, indeed we see this works. And if I confirm this, the rest of the page loads. So that's how we can import a script. One problem we're facing here is that this blocks the rendering of the page until the script is done. And in the case of an alert, the script is really only done when the user confirmed the alert, so when we close the alert. To make sure that the page loads first, we can do one simple thing. We can take the script, take it out of the head here, and move it to the end of the body, so that the browser has a chance of first parsing all the HTML code and finishing that rendering before it executes our script. And later I'll show you an alternative strategy to that as well, but for the moment we can do that. If I now save this and we now reload, you see first everything renders, then we can click OK, and then it finishes. Now actually the font only came in after, but that's something we can work on later. For the moment, this is better than what we had before because at least the majority of this file is now done loading before the script executes and blocks the browser from finishing this up. So that's the basic setup we'll work with. Now, we will also depend on the code I run here in the vendor.js file, and therefore you should import that as well. And you should import it before you import the app.js file, because the code we write in the app.js file will depend on the code in the vendor.js file, and the order does matter in JavaScript. So we have to import the thing we depend on before we use it. So we first import from our assets folder, scripts folder, vendor.js, and then you have your import to app.js, so that in the app.js file we can actually work with the things that are happening in here, even though we don't fully understand what's happening in there yet. So that's the finished import setup we need. Now with the importing done, we can dive into actually writing some JavaScript code. So it's time to write some JavaScript code in this app.js file, and for that I'll first of all clear the alert code. Now our goal is to write a very basic calculator here, where we can enter a number here and add this to the last number we entered up there. So basically a calculator where we can always work with two numbers and add a new number to the old result and so on. So that's the goal here, such a basic calculator. Now for that we'll need a couple of important pieces that will actually be found in most JavaScript programs. For example, variables and constants. That's a core feature not just of JavaScript, but of most programming languages. Now, what are variables and constants? In JavaScript, you define a variable like this, and I'll dive into the exact meaning here in a second. Now, what a variable is it's a data container, or data storage, you could say. In most programs you're going to write, you're going to work with some data. Be that a username entered by the user, which you then use to log the user in, or as in the example of our calculator, be that our most recent result we have and the number the user just entered, which we want to add. So that would be data that we want to store because our program needs that data to work correctly. For example, in the calculator, we need the old result and the number the user just entered. So we need these two pieces of data to derive the new result. So we need these two variables to get our new third variable, the current result. So a variable is a data container which holds some data. And in JavaScript, we create a variable by using the let keyword, which you see here on the left, then a name of your choice with some naming rules in mind, which I'll dive into later. Then an equal sign, and then the value you want to store in the variable. Now, with a variable created, you can also always reassign it and store a new value in there. So here I'm using the existing variable username, and I assign a new value to it. Now, I only need the let keyword, which JavaScript understands, if you introduce a variable for the first time. If you then assign a new value to it, you don't repeat that keyword. So you only need the let keyword to let JavaScript know, hey, here's a brand new variable my program will need. If you then use that variable thereafter, you do that without let. So a variable is a data container where the value can change. Doesn't have to, but often it will. Now you also have a special form of that variable, you could say. You have constants. For example, let's say you have a total amount of users in your application, which is kind of fixed. Now that's still a data container, but instead of with the let keyword, you created with the const keyword, another keyword which is built into JavaScript, which JavaScript recognizes and understands. Now the special thing about constants created with the const keyword is that there you can't change the value. If you try to do that, you'll get an error. So there, the values must not change. Now you might wonder why you would have some values stored in a variable if that's not really variable, if it can't really change. And the answer is, sometimes in your code, you have values which never change, which you still want to store in such a data container so that you can initialize them in a central place, let's say at the beginning of your file, and then use them throughout your program. Maybe use the same constant multiple times in different places so you will always reference the same single constant. And if you then ever, in code, when writing your code, you change that value, you change it in one place instead of 10 different places. But that will become clearer once we start writing some code, which we'll do in a second. For now, just be aware of these two different ways of creating variables with let and with const, where variables with let can be changed, with const they can't be. The general syntax is keyword, name, and then if you want to store a value right away, equal sign at the value. And also one little hint right away, you typically want to use constants as often as possible, which might sound strange at first because they're restricted in what you can do with them, right? You can't change them, but that's exactly why you want to use them as often as possible. It makes your intention very clear. If you have a value which actually never changes throughout the life cycle of your program or of the part of your code where you use it, well, then you want to make that clear so that if any other developer ever reads your code, quickly understands that this piece of data is never going to change. It simply makes your code easier to understand for others. Now, that was a lot of new and very theoretic knowledge. It will make more sense once we use it, so let's use it. Back in our calculator, we can already start thinking about data containers we might need in there. And there, one value that immediately comes to my mind when thinking about a calculator is the result. So we can create a result variable with let, so with this special let keyword, which JavaScript understands, and then give it any name you want, like result or current result. Now, regarding the name of your variable or constant, there are a couple of rules and recommendations you should keep in mind. There are certain allowed and not allowed names. So allowed is this name, for example, username, written like this. And it's a best practice to use this special naming convention, which is called camel case, which means that your name starts with a lowercase character and is only one word. So there are no blanks in there, no white space. That would actually be forbidden. But every word inside of the word, like name here in username, starts with the uppercase character to make that more readable. So that would be a variable name which is allowed. It also is a good name because it describes what's in the variable. So here we would probably store the name of a user. So that's a better name than what the user entered, because it might not be clear if what the user entered should be a username or a password. So you want to give the variable a name that describes which kind of data you're storing in there. By the way, also important, JavaScript is case sensitive. And this means that it really matters whether a character is a capital character or not. So username, written the way it's written here on the left with a lowercase u at the beginning and then the uppercase n in there, is not the same as if it were written with an uppercase u at the beginning and otherwise the same. So the casing in the names you choose really matters, and that's important to keep in mind. Now, also allowed would be a name like this. It's basically similar to the first example, but this also includes a digit because your variable names can be made up of any letters or digits. You can also use the $sign special character, and your variable name can even start with it. You can use it anywhere in the variable name, but it can even start with it. Similarly, you can also use the underscore character at the beginning of your variable name or anywhere inside of it, so that's also allowed. Now, there are a couple of names which are not allowed or not recommended. For example, username like this. This is actually allowed, but it's a bad practice. You should use this camel case notation on the left with lowercase starting character, one word, and each word inside of the word starting with the uppercase character. So here, what you see there is actually another convention called snake case, which you have in some other programming languages like Python, but not in JavaScript. So whilst this technically would be a valid name, you can use an underscore here. Whilst this would be a valid name, it's not recommended. Instead, use the version on the left. Now, what's not recommended, but more importantly, not allowed, is, for example, a variable name like this. Whilst I did say that you can use any name that uses letters or digits, you must not start with a digit. So your variable name or your constant name, and everything I explain here is true for constants created with the const keyword as well, these variables and constants must not start with a digit. Now, there also are special rules when it comes to special characters. You can use $sign and underscore at the beginning of your variable or anywhere in your variable, but you must not use other special characters, neither at the beginning of your variable nor anywhere else. So dashes or white space is not allowed. The underscore is allowed, as mentioned on the left, but other special characters are not allowed no matter where you plan on using them. And the last important thing you should keep in mind, in this course you will learn about a couple of keywords, like let and const, and using these keywords as names is also not allowed, because how would JavaScript be able to find out whether you want to use the keyword here or your variable, right? It wouldn't, and therefore this is not allowed. So now that we know what's allowed and what's not allowed, let's go back to our code and write some good code. So I got the current result variable, and now we could write the variable just like this. Now in JavaScript, you don't have to initialize this variable with a value, so you can leave it like this. So now it's an uninitialized variable. You could also say, and that's a term you will hear in other programming languages as well, this variable is now declared. The program, JavaScript, is now aware of its existence, but it's not initialized or defined yet. It has no value yet, or no value set by you. So you can leave it like this, and sometimes this is just what you need. Sometimes you have certain variables where you don't really need a starting value. For the result, however, I'd like to have one, and therefore I'll add an equal sign, and then set an initial value which could be 0 here, the number 0. And I'm using a number here because, of course, I want to use this variable in some calculations later and add numbers, deduct numbers, and so on. And therefore, having a number here with which we can do mathematical operations makes a lot of sense. Now, to conclude our first line of JavaScript code we write, let's see how we end this line. We could end it like this and just go to the next line to write the next piece of code. But you'll also often see code where we use a semicolon to finish off this line. Now in JavaScript, using the semicolon is generally optional. I'm saying generally because there are some very rare niche cases where it's not optional, but you can avoid these cases typically, and hence you can write JavaScript code without semicolons. And you'll see certain tutorials or guides which actually recommend that you don't add a semicolon. Ultimately, it's up to you whether you want to end each line of code, and that's not just the case for variable definitions, but for any code you write, basically, whether you want to end these lines with semicolons or not. I personally like to do it also because there are many other programming languages where it's mandatory to use a semicolon, and it's easier to switch to those if you're used to adding it, but you can also avoid it and just use a new line to, well, write a new expression. It's up to you, just whatever you use, you should then stick to it and be consistent. So I will go with semicolons, not just here, but throughout the rest of the course, but it is up to you. So we wrote our first line of code, and we're setting a variable here, and this variable, of course, doesn't do anything yet. Now, let's do something simple. Let's, for the moment, not care about what the user enters here, But let's make sure that we actually right away have a simple mathematical operation where we output the result down here in the result part of this screen. And therefore, I want to set current result to a new value, and that new value will later be the user input. But since we don't really fetch this yet, I'll use a dummy value here, let's say 10, but you can use any number you want, and add this to the current result. So let's say current result plus 10, and then store this value back in current result. So here a couple of things are happening. I'm again referring to the current result variable here on the left side of the equal sign and on the right side. And if we start on the right side, I'm using the current value stored in current result, and I'm adding a value to it. In this case, 10. I'm adding by using this plus operator. Now, operators are something we haven't heard about yet. What are operators? Operators are syntax features, or a syntax feature in JavaScript that allows us to manipulate values, you could say. And there are the typical mathematical operators you're used to. Plus, minus, then the asterisk operator, the asterisk character here to multiply two numbers, and the slash to divide two numbers. There also is a modulus operator, the percentage sign, which divides two numbers but doesn't return the result of the division, but the remainder, so the part that remains if a clean division without a decimal value as a result isn't possible. And there also is the exponentation operator, which allows you to, well, use exponentation on a number. Now, these are the mathematical operators, which you typically also know from math. There also are other operators in JavaScript, like the assignment operator, which we already used to assign a value to a variable, the equal sign. So here in this line of code, we're using two operators, the plus operator to combine two numbers. And now this combination, this operator, yields the result of this mathematical operation. And we then assign this result we're getting here with the equal sign to the value on the left, or to the variable on the left. So here, current result gets overwritten with the result of this operation. And now we use current result on both sides of the equal sign, but the right side will execute first. That's something you can just keep in mind. And therefore, we'll use the old result, 0, here, add 10, and therefore we now have 10 as a total result, and then we override current result with it. So we only override it after we're done with this calculation, so that we don't try to override it with a value we depend on or anything like that. So now current result after this line was executed will store a value of 10. Now to output this, we can use one of the things I'm providing here in Vendor, and we'll learn what exactly that is in just a second. For now, we'll use this output result thing by simply writing output result here, and then adding parentheses, opening and closing, and in there you can pass in current result, just like this. Also add a comma, and thereafter two single quotes with nothing in between. Again, I'll come back to what this is and what this does in just a second. If you do that and you now reload your page, you should now see result 10 down there. That's just the result of our code which executed here. We're calculating this result, storing it here, and then what this thing here, which we're getting from the vendor file, what this does is actually, it just takes whatever we pass in here and outputs this in this part of the HTML page. And throughout the course, it will become clearer how this works. For the moment, we can just take it for granted. So we had a first basic look at a variable, at an operation, and then at this thing here, which we don't really understand. Let me come back to that operation. Here we use two operators, but as I mentioned, there are a couple of operators available, actually more than the ones I just showed, but even with those which I did show, all these basic mathematical operators, you can do a bunch of things. And you're not limited to two operators per line or to one. You can also add the asterisk here, the multiplication operator, and multiply this by 3. And JavaScript by default follows normal mathematical rules, where it will now first execute 10 times 3 and then add this to current result. You could change that order, however, by adding parentheses, just like you do it in math. If I add parentheses around that, now JavaScript will first add 10 to current result and then multiply the result of this with 3. And of course, we can then also divide this by 2 and subtract 1, or whatever you want. You can have any mathematical equation here, any mathematical operation here, as long as it should be where you can use parentheses to group the different mathematical calculations together if you need to do that. So now if I would run this, for example, I get a result of 14, because we have 0 plus 10 times 3 divided by 2 is 15, minus 1 is 14. So that makes sense. Now, with that out of the way, let's think a bit more about the values we're actually working with. I added a number here, but numbers are not the only values you can use in JavaScript, and actually in all other modern programming languages. Now let me also make clear what output result really does here. This does something which is called call a function, which I'll dive into later, so we can ignore this for now. In the end, it triggers some code which I defined here in vendor.js, and this code uses 2 pieces of information which I kind of forward to it. Again, we'll figure out the details of what this is and how we use it later, because we'll write our own functions then. But in the end, I push this data to this thing in Render. What this does is it takes these 2 pieces of information it gets and writes them into my HTML code, you could say. Because ultimately what that code does, without diving into the details, which we'll also cover later in the course because it's a bit more advanced, what this code does is it targets 2 places, 2 pieces of our HTML code, these 2 lines essentially, and overwrites the data which is hard-coded in there with dynamically derived data, well, with the data you're forwarding here. So with your result and with this empty string. That's what's happening here. So which data types are available for you to use? Well, there are numbers, which are just used, and of course, not just positive non-decimal numbers, but also negative numbers like -3, or numbers with decimal places like 22.956. And important here, numbers with decimal places, so like 22.956, are called floats or floating point numbers. Numbers without decimal places, like here 2 or -3, are called integers. Now you, of course, use numbers for any code where you need to calculate something or where you just need to work with a number. And of course, typically that's a lot of code. Whether you're having a calculator like we're writing it, or you're working with some prices or something like that, you would typically work with numbers, of course. Now, you don't just have numbers in code, however, sometimes you also need text. Let's say you're working with the name of a user who logged in, or you want to show a message to the user. Then you're working with text, or also called strings. And it's not just called strings in JavaScript, but in other programming languages as well. So if I say a string, I mean a text type. Now you can actually create a string by wrapping your text between single quotes, double quotes, or these backticks here, which you find on your keyboard. All 3 creates a valid string. You can use whatever you want, you just should be consistent, though the third option here, the backticks, that's kind of special. I'll come back to what's special here later. For the moment, use either single quotes or double quotes. And then again, be consistent and always use that. So that would be important for outputting results, for gathering user input, for showing messages, things like that. Now we can see both types in action here in our program. We got a number here, we got a bunch of numbers here, and this thing here, this actually is a string. It just happens to be an empty string. Now with empty string, I mean that this is just an opening and closing single quote, and I could have used double quotes as I mentioned, but there's nothing in between. Because this output result thing here actually is responsible for writing to 2 places in my web page, and for now I'm only interested in writing to this place here and output my number, I'm not interested in writing to the other place, and therefore I tell it to write nothing to that other place. Now we could actually write our log here to the other place. And that could be done by creating a new variable, let's say calculation description. And you can use any name you want here. I just try to describe what I'll store in this variable. And what I will store here is a description of the calculation we just ran. And that would be that we had 0 plus 10 in quotes times 3 divided by 2 minus 1. Now the important thing here is this is now not a mathematical equation which will be executed by JavaScript. This is treated as text, and therefore JavaScript won't even try to execute it in a mathematical way. Instead, we can now pass calculation description to this output result thing. So I'm referring to this description here. And what will now happen is that you see this text here once you reload this page. Again, this is just the text I just entered. It looks like some mathematical equation which should be executed, but since I'm not using numbers here, but I'm wrapping this in quotes, I'm telling JavaScript, this is some static text. Don't touch it, don't try to execute it, take it as text. I could be saying hi there in here as well. If I would do that, then we would see hi there here. But of course, I just want to, in this case, in this application, log my calculation, which I effectively have up there. And therefore, this is what I use here. If I would use current result in here, JavaScript also wouldn't try to look into this variable. Instead, it would take this as part of the string. And hence, if I now reload, it would say, well, this here. It would not give us the value which is inside of current result. Instead, it would just take this as some text which it should output. If you would want to use the value here, you would have to do something which is called string concatenation, which is you build a string from multiple substrings. So here we could say this opening bracket, the opening parentheses here, that's in a string. Then with the plus operator, we add current result, now not between quotes, but just like this, and therefore JavaScript will now go ahead and look into this variable. And then I will concatenate this string. So now again, between quotes is this string. The pluses here are also not between quotes because I don't want to treat the plus operators here as strings, but instead as normal operators. Now we used plus before with numbers. JavaScript actually can also work with plus if you're using it with strings. Then it will not try to use plus in a mathematical way. Instead, it will just combine multiple strings, so multiple text pieces, to a longer text piece. And that's what's happening here. We're combining this parentheses with the actual value that lives in current result, and then with this part here to a longer string. And actually here, you should add some white space so that in the final text which is created, you have some empty space between the plus and the value that's stored in current result. Now the output you'll get if you reload might not exactly be what you want, because it actually yields 14 here instead of 0. But if you take a closer look at your code, that makes sense, because current result is 0 here, but then we calculate a new current result. So if I then use current result here, I of course take this current result and not the one I had up here. The reason for that is simple. Your JavaScript code gets executed from top to bottom. Actually, your HTML file gets parsed from top to bottom by the browser. And if you then import some JavaScript in there, well, that file gets evaluated and executed by the browser. And the code in there also gets executed from top to bottom. And that's default JavaScript behavior. And hence, of course, if you do something in this line and then you use it in the line thereafter, you get the result from this line and not the result from the first line. It would be pretty bad if that would be the case, because then you could never do anything in your code. So to print 0 here, we would either have to do this before we execute this line or store this initial value in another variable. And that's actually where we could use a constant. Let's say we're writing a program here where we want to initialize our current result with a default result value. And I'm naming this constant here, default result. You could pick any name you want. Now I'm using the const keyword to indicate that the value I store in here will never change. and I store 0 in here. Now we can use the default result here to initialize the variable. Yes, you can initialize a variable with the value of another variable or of another constant, and that's exactly what I'm doing here. The result of that is, if we now change current result, we can do that because that's a variable created with let. We couldn't change default result. So if I would try to do that here, and I now save this, you will actually see 0 here because our script broke. And you can see that in an even better way if you go to the developer tools here in Chrome, which I recommend that you use. You find those in the view menu and then developer tools, or by using the shortcut you see there. Now, what are these developer tools? I'll have a whole module after this module where we dive deeper into them and what you can do with them. In general, that's simply a tool built into the browser, which you don't typically see or use if you're using the browser as a normal, user. But as a developer, this is a special feature built into the browser that helps us understand our code, look behind the scenes, have some insights in how our code executes, trace and fix possible errors, and also see error messages or info messages being output here. So these are the developer tools, a crucial feature which do not just exist in Chrome. Firefox and Edge also have developer tools built in. Chrome just has very good ones, and therefore that will be the browser I use in this course. But again, I'll have a whole module where we dive a bit deeper into developer tools and what we can do with them after this module. And in these tools, if you go to the console here, so to console, you should see an error, assignment to constant variable. That's a problem. Your browser complains about it because that's not allowed. So that's not allowed, but assigning to current result is allowed because that's a variable. But since I now store this default result, which I then use to initialize current result, I can also refer to this down there when I output my text or when I generate my text. We can refer to it here and here, so I'm referring to default result in 2 places of my code. I'm never changing it though, because that wouldn't be allowed. Now we introduced a constant, and you might be wondering if we're not implicitly still changing the constant with our code. Because I initialize current result with the value which is stored in my constant, and since I thereafter change current result, you could think that implicitly we also change the constant, right? Because we set those equal in this line. But it's important to understand that indeed we are not changing the constant here, because here we're copying the value that's in the constant into this brand new variable. So if we thereafter change the variable, we're changing the copy. The original constant and its value are untouched if we then change the variable. That's something important to keep in mind here or to understand. And therefore now if I reload, we see this result and we see the correct text representation of this calculation, because we're now using this correctly and we're building a text with our default value which never changes. So this shows us constants and variables in action. It shows us operators, both used with numbers and also with text. And we got something on the screen. Not too bad to get started with. Now let me have a closer look at our text here, at our string, which we're combining from a couple of substrings. Now for one, I mentioned that you can use single or double quotes, and the decision is really up to you. You can go for either of the 2 solutions. I will use single quotes throughout the course, but that's just my personal preference, not something you have to use. However, you should be consistent and stick to your choice thereafter. What you can't do is mix your characters. So you can't open a string with a double quote and try to close it with a single quote. This will not work. You always have to close a string with the character, so with double quote or single quote, with which you opened it. So this string here, for example, is opened with a double quote, and then I have no other double quote, therefore this string never gets closed. That actually therefore is invalid JavaScript code, and hence my IDE already complains here that this is an unterminated string literal, so that this string has no end. And if we would try to run this code and reload our page, indeed if you look into the developer tools again, you'll get an error. Now the interesting thing actually is if I do close it with a double quote, now everything in between will be treated as one text. So when you open something with single or double quotes, everything in between the opening and closing single or double quotes will be one piece of text, which makes sense if you think about it. How would JavaScript know whether you want to create a new string there? There also is nothing like a string inside of a string. Instead, if we now reload the page, we got rid of our error, but now our whole "we want to create a string" code is actually treated as one piece of text and therefore output as such here. So you always have to close your string with what you opened it, and everything in between will be treated as text. Now you can take advantage of this if you, for example, want to print this single quote character. Because right now, if I use just single quotes and no double quotes, and the same would be true if you were just using double quotes and no single quotes, if I reload, we get the output we saw before. But what if I actually did want to output a single quote character here? Well, then you could try to add a single quote inside of a single quote, but this won't work. Instead, what now happens is that JavaScript creates a string here and creates a string here, and in between it has this bracket, which actually leads to some invalid JavaScript code overall here, because we're not using any operators that would try to concatenate that. And even if we would, a single opening bracket like this is not valid JavaScript code. So if you want to output the single quote character, you can actually take advantage of the double quotes and, for example, wrap your code, your string that contains the single quote which you want to output, between double quotes. Because now we use double quotes to create the string, everything in between is treated as text, and therefore if we save that and we reload, now we see the single quotes here as well. So that's one way of outputting single quotes if you wanted to. You could deviate from the rule of sticking to either single or double quotes and make an exception if you really want to output the single or double quotes you otherwise use as your string delimiters. Here, of course, I don't really want to print my single quotes, so I don't need to do that. Now we'll dive into strings again and again throughout the course because there are more things you can do with them. One thing I want to do right away is restructure this string. We're building our string here with 3 pieces of text, you could say, with the opening parentheses, with this code thereafter, or with this text thereafter, and with the value that's stored in default result. Now, in such cases, you can actually also use backticks instead of single quotes. So this is now not a single quote, this is the backtick character which you find on your keyboard. Get rid of all other single quotes you actually have, and get rid of these pluses you used to combine your strings, only keep the plus which you want to output on the page, and replace the closing single quote also with a closing backtick or with a backtick. So now I got 2 backticks which surround my text, and therefore now if I save this, unsurprisingly here I say default result instead of the value which is actually stored in that default result constant. But now backticks give you access to a special syntax. You can now use a $sign in here and then an opening and closing curly brace. And now you can put your variable or any expression which yields some result which can be output as text. So you could also have a calculation like 1 + 1 in here. So you can put that between your opening and closing curly braces now. And what this does is it tells JavaScript to output the value that's in this constant, in this case, in this place of your text. So it will not output the $sign or the curly brace. Instead, it will output the value of the expression, as it's called. So in this case, of the constant you have between the opening and closing curly brace. So if you now save that file and you reload, you see 0 here, which indeed is the value we have in default result. This only works with backticks. If you use single or double quotes, this $sign curly brace thing would be treated as regular text and therefore output as such, as you can see. So this is a really nice feature using these backticks with this $sign curly brace thing. If you have some text in which you want to embed or inject some dynamic value, so the result of some calculation or the value that's stored in a variable or of a constant, then this is simply shorter. It saves you the manual string concatenation, which we previously had to do, where we combined multiple strings with the plus operator. This is simply a bit shorter and therefore how you typically would build a string that includes dynamic values. This overall construct here is called a template literal. So if you ever Google for JavaScript template literal, you'll find, well, exactly this piece of syntax. Now there's actually more to it, and we'll dive deeper into it throughout this course, but this is the most basic and I would say most important form of using it, because that's the form where you will work with it most often to have some text into which you inject or embed some dynamic value. Now, some additional information about strings and template literals as we have it here. One convenient thing about template literals is that you can easily write multi-line strings there. Now, with multi-line strings, I mean strings which really do have a line break in them. So let's say here, in front of the asterisk character, I add a couple of line breaks, and hence this string looks like that. Might look a bit strange at first, but this is valid JavaScript syntax. We open a string here, we close it here, and since it is a template literal with backticks, this is allowed. For a normal string with single or double quotes, this would not be allowed, but I will come back to that. Now, if you save that and you reload this in the browser, you'll not see a difference, though if you have the developer tools opened, which you can always open with View, Developer, Developer Tools, and you then click on this select icon there, and you select this part of your web page, you will see that indeed the white space is considered here. It's just the browser and the default behavior of the browser and the h2 element that basically strips this redundant white space. But it's output there, and depending on where you output this, in which element and how that element is styled, you might also get that white space or the extra line break here in your web page. So the fact that we don't see the line break here in the middle is really just due to how this is styled and rendered. If you go down here to the element style of the h2 element, which is selected, and you add white space pre, for example, then you will see the white space here as well, because this is some CSS styling which does not omit the extra white space, but instead render it. Here, in this case, that means it renders this extra line break. So you can easily add line breaks here when using the template literal syntax. This can help you with readability, because you might be able to read long strings easier or better here in the IDE if you add line breaks, but you should always keep in mind that this is not just a visual thing for you in the IDE, but that the line breaks really are part of the string. The same is true if you indent this. For example, you could think that if you write it like this, it's a normal string, but it's more readable to you as a developer. Well, if you save that and you reload, our styling will be lost because we reloaded, but here on the right you can see this extra white space, it really is part of the string. And if we re-add this style here to our h2 element here in the developer tools by setting white space to pre, you see we really do have the line break and the extra white space in here. So be careful when you use that, and really only use the line break or extra white space feature here if you want to build a string that has the extra white space or that has the line break. Don't do it just for readability. Now, if I come back to normal strings, there, let's say we have an error message, which we don't need for this app, for this website here, but just to demonstrate how we work with normal, which means non-template literal strings. Then, of course, you use single or double quotes, and you might have a message like an error occurred, something like this. If you would want to split this across multiple lines, you have two options. You can close the string here by adding a single quote and then reopen a new one and combine them with a plus and then add a line break. This is valid JavaScript code. You can span expressions that use operators across multiple lines. That would be possible here for mathematical operations, just as it is possible for concatenating strings with the plus operator. And here you can also indent, and if you do this and you would output this somewhere on the web page, this indeed would not include a line break and also not extra white space, because this is really just something we do for us here in the IDE to make this more readable. The string that's getting constructed only consists of these characters between the single quotes. So there's no line break in there, and there is also no extra white space. Now, if you would want to add a real line break here in a string enclosed by single or double quotes, that is possible with a special character or a special combination of characters. You add a backslash and then n. What this will do if it would be rendered to the screen is it will not output backslash n there, but instead it will treat this as a line break. To show this, let's temporarily output the error message here instead of the calculation description. Just temporarily so that we can see that. Now with that, if we reload here, we see an error occurred. And if we go back and add our good old style here to the h2 element right in the developer tools down there by setting whitespace to pre, you see the line break here as well. And you can also see it here. There is a line break after error. So with this backslash n, you can add a line break in a string no matter if you use single or double quotes. You could also use this here in the template literal, by the way. It's also supported there, but there you don't need it because there you can just add a normal line break, and since you're in a template literal, that will add a line break to the string as well. So there, this is available. Here in a normal string with single or double quotes, you need that backslash n thing. And by the way, using a backslash in a string has a special meaning. It escapes the character that comes after the backslash, which means the character after the backslash is not treated as a normal character with its normal meaning, but instead combined with the backslash, it gets a special meaning. In this case here, we escape the n, and therefore we don't just output an n here, but instead backslash and n combined mean line break. You have more such combinations, and attached you find a list of available shortcuts or combinations here in your strings. One other important combination, for example, is backslash and then a single quote. This is helpful if you want to output a single quote in your string, especially if your string is enclosed by single quotes. Without the backslash, we would have a syntax error here, because what happens is we open a string with a single quote. Here we then close it, and then here in this case we have a redundant single quote that tries to open a new string, which then never gets closed. So we have to tell JavaScript that this single quote should not be used as it normally uses single quotes, i.e. to close that string, but instead that we want to output this single quote here as a normal character in our text. And adding a backslash in front of it escapes the meaning the single quote would otherwise have, and therefore allows us to do that. Of course, an alternative always is to use double quotes to surround the string instead of single quotes. And then you can use single quotes in the double quoted string without issues and without escaping it, because it then won't have that special meaning of finishing your string or of closing your string, because you can only close a string with the character with which you opened it. And since here we opened a string with a double quote character, we can only close it with such, and JavaScript won't interpret a single quote as a please close my string character. Still useful to know that you could escape it like this. By the way, if you want to output a backslash in a string, you need to escape this as well, because otherwise a single backslash always tells JavaScript that the character after the backslash should be considered or should be escaped. So if you want to output just a backslash, you put another backslash in front of it to tell JavaScript, hey, the character after this backslash has a special meaning, and double backslash then effectively tells JavaScript, I want to output a single backslash here as part of my string. So these are some of the useful things that you should know about strings. You will encounter them throughout this course and throughout your career as a developer. You don't need to learn all these things by heart. The attached list of escapable characters might be useful, though backslash n, backslash backslash, and backslash single quote are the most important ones, I would argue, the ones you typically use most often. And being aware of the template literal, that you can interpolate content here, and that you can easily add line breaks and white space in here, that's also something which is good to know, I guess. And with that, I reverted all of that. Again, I'm sending calculation description to output result, and I deleted the extra error message variable because we don't need it here to continue. I just wanted to dive into some of these string specialties and things you should know. So now we got some core basics out of the way. We're able to work with some basic JavaScript with variables, constants, operators, numbers, and strings, and we're outputting that here on the screen. But the calculator, of course, is not very responsive. All that's getting output here is kind of hard-coded into the script here. We're not using any user input. We're not really doing something when the user presses buttons here. And therefore, this is not really a dynamic script. Instead, it just runs from top to bottom when we load the page, and therefore it immediately runs when the page gets loaded, and it then, well, does all these steps and outputs the result here, which is nice, but again, which isn't really something interactive or dynamic. So it's time to change that. And for that, we need a brand new language feature, which I haven't talked about before, and that would be functions. I like to refer to functions as code on demand. Now, what do I mean with that? A function is a language construct, which you don't just have in JavaScript, but also in other programming languages, which basically allows you to define some code, which you then execute at a later point of time. You define a code in JavaScript like this, you use that function keyword, then you use any name you want for that function, then your function can take something which is called parameters, so some input to the function if you will, and then you have the so-called function body between curly braces, which is the code you want to execute eventually. Now, as I said, this function can have these parameters, so name in this example would be a parameter, and it can also return something, which this example function here doesn't, but which we'll see in action in this module. Now, when you have a function defined, the interesting thing here is that the code in there doesn't run immediately when your script gets first executed. Instead, JavaScript just sees that function and kind of registers it, stores it in memory, you could say. You then execute the code in the function by calling that function. You call a function by using its name, and then you add parentheses, and if that function takes any parameters, any input, which this function does, and you can have more than one parameter, separated by commas by the way, but you'll also see that. So if a function takes parameters, you pass in a value for these parameters. Then this code gets executed with the data you entered as parameters, and you can call such a function as often as you want, wherever you want in your code, with different parameters if it takes parameters. So every function execution then runs independent from the other previous function executions you might have had in your code. And the great thing about functions is that this now gives you way more flexibility. Because thus far, with all the code we write here, we basically write code which always executes from top to bottom when the script is loaded, which is the case when the page is loaded, and therefore all this code runs immediately. Now with functions, we can define code that should run later, and we can then take such a function and actually attach it to the buttons here to make sure that only when a button is pressed, the function runs. And this then allows us to write code which doesn't run immediately, but which allows us to provide some interaction to our website, to only run some code when something happens, for example. And of course, you're not limited to only running functions when a button is pressed. You can run functions based on a broad variety of events or manually call them in your code whenever you need to do that. And actually here, we are calling a function. I haven't really had a closer look at this yet, but outputresult is a function I provide to you because it's defined here in the vendor.js file with the function keyword, then the name of the function, then in this case 2 parameters, and then some code which is executed when the function is called. In this case, this code here simply reaches out to our HTML page, you could say, to our web page, and changes some text there. It displays the result of the calculation and this calculation text. So these 2 pieces here, which are changed in our web page, that's done by this function effectively, because this function communicates with that part of the HTML page with the help of these constants, which in turn set up connections to these places in the HTML code, you could say. So this function is registered here, and we can call it from that file because we import this file after the other file, right? The order matters, of course. So we have access to that function, and I'm calling that function here, as I explained on the slide, by repeating its name, then adding parentheses, and between the parentheses, I pass in the values to the function, which this function can use. So here I pass in current result and calculation description, so I pass in the values that are stored in these variables, and therefore this function receives these values, and that's important. It receives the values, not the variable names or anything like that. It receives the values stored in the variables, and therefore in this function we can then use these values to, in this case, output it in our HTML page, but you could do whatever you want with these values. So let's write our own function then, so that we get a better feeling and understanding for how functions work and what we can do with them. So which function could we write? Well, let's say we want to make sure that at some point of time in this module, we can click the plus button and add whatever we entered here to our current result, which initially is 0. And then if we type 5 here and click plus, we want to get 5. So the new result is then 5. If I thereafter type 10 and I click plus, we would get 15, right? So that would be an idea to get started with. And for that, we need a function, or we could add a function that does just that, that adds 2 numbers. So for that, we can define a function, and it's up to you where you do that. You can actually do it kind of at the start of your script, maybe below your variable definitions, or you can actually also do it at the end of your script, and JavaScript is smart enough to kind of read your entire file before it executes it, and it will therefore find any functions you use so that it then automatically pulls these functions to the top, so to say. So that if you define a function down there, but you then use it somewhere above its definition, you can still execute that code without an error. Something which, by the way, is not possible for variables and constants you define with let and const. But I'll come back to this in a second. For now, let's just add a function here, let's say, and let's name it add, and you can pick any name you want here. The idea for the name here just should be that it describes the action this function will perform. So if it's a function that adds 2 numbers, something like add or add numbers makes sense, instead of give me 2 numbers, which describes what it wants to get as an input, but not what it does. You also don't want to have something like result as a name, because what does this function do? It doesn't tell us anything. It gives us some result, sure, but for which operation? So here add sounds like a fitting name. It makes it clear that this is a function which will do some addition. And then, as I said, a function can but doesn't have to take parameters. Now in JavaScript, and you'll see that throughout the course, of course, there are functions which work without any input. Let's say you have a function which kind of reads something from the HTML page. This probably doesn't take any input because inside of the function you have all the information you need to kind of reach out to the HTML page and get some data from there. On the other hand, a function which should add 2 numbers probably needs these 2 numbers which it should add. So we should provide 2 parameters here. And you can give these parameters any name you want. So I will go with num1 and num2, but you could go with a and b, or with number1 and number2, or whatever you want. These parameters which you define here are then available in the so-called function body, which is the last missing piece on this function. You add the function body by adding curly braces here, like this. And now important, after the function you don't have a semicolon. Now you could add one, but typically you don't do that. You add a semicolon after all these one-line expressions here, but after a statement, as this is called, which includes such curly braces like this one does here, you don't add a semicolon. You can just keep this in mind. Whenever you have some curly braces with some code, some executable code in between, you don't have a semicolon after the curly braces. Whenever you have these short expressions here, you have a semicolon at the end. So here we have a function, keyword, name, parameters, which are optional, and then the function body. And now in the function body, you can do all kinds of things. For example, we can define a constant in here as well, maybe name this result, and just add num1 and num2 here. Now num1 and num2 are like variables, though they're never defined with the let or const keyword, but they're automatically defined by JavaScript, but they're only available inside of this function body, not outside. So if I would try to do something with num1 here, after the function definition, this would not work, because num1 and num2 are variables only available inside of the function body. Now I use them here to add them together because I expect this function to be called such that whatever I get here on num1 and num2 are numbers, and therefore adding them works. And I store the result in a new constant. Now the interesting thing here is that this constant is defined inside of the function, not at the top level of our script. And that's something you can do in JavaScript, and that is actually quite normal. You can have variables and constants here at the top level of your script. This is also called in the global scope, but you can also have them inside of your function. And it's actually important where you define that, and I'll come back to that. For now, I want to calculate a result, which I only use inside of the function, and therefore we can declare and define this variable, or this constant actually, inside of that function. Now, inside of that function body, you see that my IDE automatically indents the code, which means it's not totally on the left here, but there is some empty space. This is done for readability. Technically, this is not required. Your code would run even if this would all be written in one line. So if you would move that right next to the curly braces and have that all defined in one line. But having the function split out across multiple lines and having this indentation, this empty space, simply helps with reading or understanding your function. Now, regarding the amount of empty space you have to the left, you can find a lot of discussions about that on the internet. Now here, I indented by 4 blanks, so to say, so 4 white spaces. Now you'll find discussions on the internet whether you want to use 4 or 2, whether you want to use tabs or white space. I'm a fan of white space, and I'll typically use 2. Also later, when I auto-format my document, it's configured to use 2 white spaces here instead of 4 as I have it right now. You can go with whichever approach you want. You then should just stick to it and be consistent. And you can also configure your code styling, your code formatting plugin for the IDE you're using to format your code according to your preferences. Again, my tool will later change this to 2 blanks here instead of 4 as I have it right now. You can go for either of that. You just should write readable code in the end. So this will now hold the result of num1 and num2 added together. And now what can we do with the result? Well, we can, for example, output it with the alert function. This is a function built into JavaScript or built into the browser and provided to you in JavaScript executed in the browser. So we don't need to define this function on our own to call it. It's available. It's one of the built-in functions. And there are a couple of built-in functions in JavaScript. It depends on whether you're running JavaScript in the browser or outside of the browser. But here we're in the browser, and there we have something like the alert function, which is, well, built in, made available by the browser. So alert then allows us to output a message. We could say the result is, and then this is a string, of course, add result here. And of course, you could have also used the backticks notation with this $ curly brace embedding here. Now, I do create a string here where I concatenate my result because alert actually wants a message as a parameter. And you can see this if you hover over alert in Visual Studio Code. You see this is a function, again, provided by JavaScript or by the browser. And this wants a message parameter. We can ignore the question mark for now. That simply means that providing this message is optional. So you could throw an alert without a message, which is kind of pointless though. And message here is a parameter which actually, well, should be a string because you want to output some text typically. So now I'm outputting this text here, this alert. Now if I save this and we reload, nothing happens. We see no alert. And the reason for that is that we're not calling this function yet. As I mentioned, you need to call a function in order for it to be executed. Now, how do you call a function? Well, you can just use the function name. So in this case, add. And if you picked a different name, you have to pick a different name here. And then add parentheses like this. So a bit like you defined it here, but without the function keyword and without the body. Because this defines what's inside of the function, how it works. This now calls the function. And here I add a semicolon again, because here I don't have the curly braces, I don't define the function here, I just execute this as a so-called expression. So I just have this line of code which is executed. This line of code is also executed, but it's executed such that this code is registered and stored by JavaScript. So it kind of is made aware of this function. This line then executes and calls that function. It runs that function. Now this function, to work correctly, needs two parameters, also called arguments. It needs a num1 and a num2. And now here, of course, you don't provide num1 or num2, so you don't repeat these names. These are just internal names for these automatically created variables you can use inside of the function. Instead, here you now provide the concrete values that the function should use for running. So something like 1 and 2 if you want to add 1 and 2 together. So now num1 would be set to 1 and num2 would be set to 2 for this function execution. And as I said, you can now run a function multiple times by executing it again with 5 and 5, for example. Now we would execute the function 2 times, one with a value of 1 for num1 and a value of 2 for num2. And then the second time we run it, we pass in a value of 5 for num1 and a value of 5 for num2. And now if we save that and we reload this file, you see, since this script runs right away, we get the alert with the result is 3, because here I'm, calling this function with 1 and 2. And if I click OK, I right away get another alert, because we're running this function twice, and script execution is kind of blocked by the alert, which is why the second alert waits until we dismiss the first alert. And in that second alert, I see the result is 10, because I called this function with 5 and 5. And if I dismiss, then we see that page being rendered. So this is how we define a function and how we call it in JavaScript. Now I will emphasize again that a function can have as many parameters as it needs if it needs to have some. You can have 1 parameter, 2 as we have it here, 3, 5, 4, as many as you want. And a function can also do one other thing, which we're not doing here. It can return something. This function here executes the code which is in there. And in this case, this then throws this alert or shows this alert box by calling the built-in alert function. Now, that's something you can do in other scenarios, which we'll also cover later in the course. Of course, you might want to send a HTTP request to a server and store some data there, for example. But sometimes you also have functions which you just use to outsource some code. Maybe code which you need to run multiple times, and therefore normally you would have to copy and paste it around, which never is a great idea as a programmer. You want to be lazy, you don't want to repeat yourself, you want to write code once and then rather execute it multiple times by referring to the function it's coded in. And therefore you could have a function which is simply there to outsource some functionality. In this case, a function that adds two pieces of information together, which adds two numbers together. So in that case, you might not want to alert or do something inside of the function. You maybe just want to return the result. And that's something you can do with the return keyword, which is built into JavaScript. So now we saw a couple of keywords, const, let, function, and now also return. And return does what the name implies. This function now returns the value that's stored in a result as a result of this function call. This means that when we now execute add like this, nothing will happen if I reload the page. You see, nothing happens. We don't see anything. Because now the function itself doesn't do anything that has a visual impact. Instead, it returns a value. So that means that add now gives us a value. Just like the plus operator or the multiplication operator gave us a value. If we add two numbers together, this gives us a value, and we store that value in a constant. So now calling our function gives us a value, and that means we can store this in a variable, for example. So here we could say, I want to have my addition result, and you can pick any name you want, store it in this constant. And I'm using a constant here, just as I do it here in my function, because I never assign a new value to the addition result or here to the internal result. I never assign a new value with the equal sign again. And if you never assign a new value, then this effectively is a constant, and then you should mark it as such to make it clear that this will never change. Makes it easier to understand your code for other developers. So now the result of this function call is stored in addition result. And this means that we can now use it anywhere in the code. For example, we could now use addition result to set our current result equal to it, like this. Of course, this is now kind of redundant. we store the result of this function call in a new constant just to take the constant or the value stored in a constant and then set it equal to current result to our variable. Of course, we can kind of shorten this and just set current result equal to the result of our function call and get rid of that other line. And now current result is the result of this calculation. So that means, of course, that if I now reload this, we see 3 down there for the result. Because I have add with 1 and 2, the result of this is 3. The result gets stored here, and then we use current result to pass it to this output result function, which is provided in the vendor.js file, which will in the end output the calculation result in this place of our HTML document. Of course, this is now incorrect. This is now not the correct description of what we did. So this is how we can define our own functions with or without parameters, with or without the return statement, and how we can call them. Now, of course, we're still calling this immediately when this code runs. So ultimately, the goal will be to connect this to the button, which I'll do in a second, but not before diving into the order in which you can define things here, and also the implication it has when you define a variable or a constant inside of a function versus outside of a function. Let's have a look at the order. Here, I'm defining my constant and my variable before I use it, right? I define current result right at the top of the script file, and then here's the first time where I try to use it because I try to assign a new value to it. And then I also use it down there when I forward it or when I pass the value that's stored inside of it to output result. Now our code would break if I would move that all the way to the bottom of the script. So if I declare my variable here. Now if we reload this page, you see 0 everywhere. And if you open the developer tools again, in the console you'll see an error, cannot access current result before initialization. Now this error message which the browser throws at us is pretty clear. We're trying to use it here, and actually the error message even gives us the line number of where this error occurred. It's this number you see here, 8. So as you see in line number 8, and indeed that's the problematic number here, we're getting an error because we're trying to assign something to the current result variable without defining it first. So in JavaScript, when using the let or the const keyword, which you should use, you need to declare your variables and constants before you use them. And declare is the part where you, well, create the variable with let or const. Then, as mentioned, for the same name, you must only declare it once. You can always reassign a value, but with let and const, you only declare it once. And you need to do that declaration before you first try to read from it or assign a value to it. You don't need to define it, so you don't need to initialize it with a value. If I just set up current result like this, this would actually be valid. If I now try to execute it, you see this runs because I declare the variable before I then use it. And since I use it by initializing it with a value here anyways, or by assigning a value here anyways, I don't need to initialize and define it up there. So doing this up here is totally optional. We don't really need to do that because I'm assigning a value down there anyways, but you need to declare it with the let keyword. Now for functions, that's actually a bit different. I could grab this function and move it to the bottom of this file. And if I do this, please keep in mind that I do call it up here. So technically before I define it. Still, if I now reload this page, we get the same result as before. And if we have a look into the developer tools, you see no new error here. The reason for that is that for functions, we have a special behavior in JavaScript. What JavaScript actually does, or what the browser actually does, is that when it loads your script, it runs through it from top to bottom, it parses the entire script, and actually it doesn't execute it right away. Instead, it just reads it from top to bottom, and will take any functions it finds in there and automatically pull them to the top and be aware of them, so to say. So it automatically registers all functions before it then really executes your script. And that's just a special behavior JavaScript has there. Therefore, it's up to you whether you prefer to have your functions at the bottom of your script or towards the beginning or somewhere in between. You just should try to find some consistent code style. Now, I personally like to have my functions towards the beginning of the file in most cases, because I think if you then read the file as a developer, you kind of see what's in there, and if you then later see that I call add, you recall that you did see that function definition above, and you don't need to scroll to the bottom of the file to find it. But there also are developers who prefer to have their function definitions at the bottom of the file. And ultimately, there is no wrong or right, it's up to you, but you should find one approach and then kind of stick to it for this program you're writing. Of course, you can switch anytime in new applications you're creating or refactor your existing code and move your functions to the bottom or to the top if you kind of decide to go the opposite direction whilst in the project. Here again, I'll have it towards the beginning, but this is up to you. Let me also reformat that, which I did with the auto formatting functionality I showed you in the first course module. So the order matters for variables and constants. It does not for functions. There's one more interesting thing in our code here, and that's that we have a constant here in the function, and we have a variable and a constant outside of the function. Now, when should you use what, and what's the difference? Is there a difference? Well, there is a difference, and generally, if you use some data only in the function, like this result, which I use in the function, I return it here, then you want to define it in the function. I could have said let result here and then just assign a new value here. And then we could even do something strange. We could say add like this and set current result equal to result. This code would technically work because what I'm doing here is I'm defining this result variable globally, so in my script. Then I assign a new value to it in a function, because in your functions, and that's one important thing to keep in mind, you can access any variable or constant defined outside of the function. So you can read variables or constants defined globally. So we can interact with this result variable, and I'm assigning a new value to it. And therefore, when I thereafter call the function, I actually don't care about the return value. I let that go into the void. But since inside of the function, I assigned a new value to result, I can use that global variable and store it in another global variable or use it anywhere else, whatever you want to do. This, however, would not be very good code because we have a function that manipulates a global variable. That's sometimes something you want to do, but often that makes your functions harder to understand and harder to predict what they're going to do. And in addition, that we return this value here is totally redundant, so not the best code we could write. Instead, it's way better if we go with the setup we had before, where we have our contained constant here, we return this, and the function therefore works standalone. It doesn't magically change our global variables. Instead, we know when we call the function, this function will not alter anything, not anything global. Instead, it will only work with its internal data and then return us. This is called a pure function. It gets some input, returns output. For the same input, it always returns the same output, and it doesn't manipulate anything global. But it is worth noting that functions can access global variables. They can also access other functions you might have defined. So you can call a function from inside a function. And that is built into JavaScript, and it's a good thing, which we'll also use from time to time. Now, the other way around won't work though. If you define a constant or a variable inside of a function, then this has a so-called local or block scope, which means it's available inside of this block. The block is surrounded or marked by these curly braces, and we can use it anywhere in this block, but we can't use it outside of there. So if I try to throw an alert where I want to output the value that's stored in result here after defining the function, you'll see that if I reload this, nothing happens. You see, we seem to have an error, and indeed, if I open my console in the developer tools again, I get a reference error that result is not defined. Because I'm trying to use a variable here in line 9, so in this line here, which wasn't defined. because, as I just explained, you can use global variables and constants and functions inside of functions, but you can't use local variables or constants or functions, so variables or constants or functions defined inside of functions. And yes, you can define functions inside of functions, something I'll dive in later. You can't use those from outside of the function. So using result outside of the function won't work because this is a constant defined inside of the function. And it won't work no matter if we use it here or here after we called the function. Because you could think, well, we only called the function here, so thereafter result has to be defined and now it should be available. Well, actually, as it turns out, if you now reload, you still get the same error here. Now in line 11 instead of line 9 because I moved that code, but still result is not available outside of the function. And that's one important thing you need to understand with JavaScript. Functions have full access to their surrounding context, so to all the variables and so on that are defined above them or outside of them. But what you define inside of a function is only available in there. The only way of kind of getting it out is by returning it. Now, at this point, you might also wonder, what if a variable is defined globally and then we try to create it locally in a function as well? So we have it declared with let or const globally, and then we want to do the same with let or const in the function. So not overwrite the existing one, but create a new one. Is that possible? And the answer would be yes. This is a process called shadowing. And in the lecture after this one, I'll dive a bit deeper into this. So the return statement is useful for getting data out of the function. There are a couple of important things to know about the return statement. For one, any code that you have thereafter, like this alert, won't execute. You see my IDE even kind of grays it out a bit. And indeed, if I reload the screen, you see everything works, but I never see that alert. In the developer tools, you'll also not see an error though, because the app didn't crash. We don't have an error. The return statement just ends the function execution, which means code thereafter isn't executed. You, by the way, also can return nothing. You might wonder why you might want to do that. For this function, it makes absolutely no sense, but you will later encounter scenarios where a function does something. Let's say it does some calculation and then sends that with a HTTP request to some server to store it there. And then you want to quit function execution, maybe conditionally with something we'll dive into later with the if statement, which allows us to check for some condition, and then exit the function if that condition is true and only continue if it is not true. So in such cases, you could return from a function and you would return nothing just to cancel function execution. Here, again, that doesn't make any sense because the function would be over after this line anyways, but it's important to understand that return finishes the function execution in case you had more code after this, which, as mentioned, only makes sense if you have some kind of conditional logic in your code. Right now we don't have that, so it makes no sense. You also must only have one return statement here. Or actually, well, you could have a second one, but because the function execution stops after the first one it finds, having a second one makes no sense. So it's not a technical error to have more than one, but you can't return more than one thing here. If you need to return more than one piece of data, actually, we'll find a solution for that later. For now, we'll just use it like this, but we'll dive into other data constructs which allow us to return or contain more than one piece of data later in this module. So there was a lot of talking about functions and variables and constants, but these are some core things you gotta understand with JavaScript regarding how code executes and how code is related. Now, our goal was to make sure that when we click the plus button, we actually take whatever the user entered here, and we then use that in this addition and generate a new result, which we then output. Now for that, we need to add an event listener to this button. And now that's something we haven't learned at all. We don't really know how to interact with the HTML page because that's a bit more complex, and I'll have a whole module where we dive into all the depths of this. For now, we can take something from the vendor.js file. We can take this add button, which at the end is a reference, a pointer at this plus button we have here. So in app.js, we can use that, replace this code here with add button, and then add a dot here, which is strange. We have never seen that before here. Let's ignore it for now. And then type add event listener, written like this. This is actually a function built into the browser, you could say, which is tied to this button, which is why we have this dot in between. And we'll dive a bit deeper into what this dot means in just a while. So for now, let's just write this. And now this is a function that takes two parameters or two arguments. And the first parameter is actually a string, which identifies the event to which we want to listen. Now, there are a bunch of available events, and I'll walk you through them and where to find them all in the dedicated module. For now, we can add click here. Now, as a string between single or double quotes or backticks, though backticks don't make a lot of sense here because we don't need to embed anything dynamic here. So that's the first parameter. The second parameter, and that's now the strange thing, actually should be a function. It's not that strange if you think about it though. Since functions are code on demand, you want to make sure that you tell the browser, that you tell JavaScript, which function should be executed if this button is clicked. So how do we now point at a function here? Well, you could do something like add here, right? You could execute your add function here. Now, this would actually be wrong. And this is one of the trickier things to understand in JavaScript or in programming in general. It's not exclusive to JavaScript. We want to tell the browser what to execute when a click occurs. Now, if we execute add like this, no matter if we add arguments or not, which we of course should theoretically though, what happens is that this code gets parsed by the browser when it encounters our script. And in the end, after registering all functions and so on, it will go ahead. It will add this event listener, but then this here tells the browser, call this function, because we have parentheses with arguments here. We want to tell the browser, however, or we want to tell the JavaScript engine, don't execute this function right away. Instead, keep in mind that this function should be executed when this button is clicked. The solution, therefore, is to not pass the function here with parentheses, but just the function name. By doing that, you're telling the JavaScript engine, when this button is clicked, have a look at the function with this name and execute it for me. So before we manually called the function in our code, because we the developers, so to say, were the one executing the function. Now we want to make sure that the browser can execute the function when the click occurs. And we don't know when that will be the case. So we want to give JavaScript the name of the function which it should call for us. We want to allow the browser to call that function for us. Here's a real-life analogy. You live in some house, some flat, and you have an address where you get your mail and so on. Now, of course, you can go down to your doorbell and ring it yourself. You can do that because you know where you live and what your doorbell is, which button you need to press. But you want to make sure that the mail service, the people delivering your mail and your packages, that they know where to ring. So you give them your address. You give them your address by providing it to Amazon or wherever you order your stuff. So now you basically tell them your address, and in this case, the name of the function is the address, so to say, where they need to ring. So that when they are there with your package, with which you ordered, they can ring that bell. That's the same we're doing here. We're giving the browser the address, the name of the function, which it should call for us when the button is clicked. So now this add function will be executed for us by the browser whenever the user clicks this add button. The thing now just is, what about these arguments which we want to get there? We don't know what to add here. Well, in the end, what should be added here is the current result and then whatever the user entered. So we need two additional pieces of information. We need to find out what the user entered, and we need to get our current result. For that, we can restructure the function a bit, and instead of getting arguments here, we can take advantage of something which I mentioned earlier. A function can read from the globally available variables. So we know the current result, of course, so we can use that here in a read-only way, so we're reading from it. We could, of course, also reassign a value to it, but here I'm just reading from it. And now I want to get the value the user entered here. Now, for that, the vendor.js file again got us covered. This user input constant, which is added globally here, that in the end points at this input field here. So we can use user input here, but now that's just a pointer at the input field. Again, without diving into too many details here, you can add dot value here, and that will actually give you the value of what the user entered. And now we get these two pieces of information from our globally available variables and constants. We then derive that result, we return that result, and of course that's another problem. We return the result, but we don't really care about the return value here. We're telling the browser when the button is clicked, click the add function. The browser, however, doesn't care about our result here. It just knows on a click, I execute this function. I don't care whether you return something, and if you do, what that would be. So we can actually change that to on that function and just make sure that we immediately change the current result. And earlier I mentioned that it's not the best idea for a function to kind of change something from outside. Well, if it's a function like this, which is very clear about that, which doesn't kind of mix some internal constant and some external global values, but which clearly only works with global values, and which we just use as an event listener, that's kind of fine. And this might sound totally arbitrary right now. You'll get a feeling for this throughout the course, promised. This is something which gets clearer the more you work with JavaScript. You in the end just want to write clear functions, which might work with global constants and variables, but which then shouldn't mix it too much with internally managed data and then some returned value, even though they're also manipulating some global value. As a general rule of thumb, you can have a function that manipulates some global variable, but then this function maybe also shouldn't return something. Because if a function returns something, it kind of signals, hey, I do something and I give you the result of that. I don't do anything else than that. If that function then starts changing something else too, that's the confusing part. If you have a function without a return statement, as we have it here, this function doesn't give us the illusion that it would return its result. It probably instead starts editing the global variables right away, which it does. And then this is clear to us as a developer if we read that code as well. So this now again makes sense. Well, now there was a lot of talking, but we now should have a setup where we actually are able to change the current result when that button is pressed. So if we now save that and we reload here and I enter a 5 and I click plus, nothing changes. Now why is that? Well, we're almost there, but keep in mind that we're calling output result here at the end of our script. Now, as I mentioned before, the script runs from top to bottom, right? So that, of course, means that after that, it's done and it doesn't run again. The only thing that runs again is this function whenever we press that button, because we, when the script executed, told the browser to be aware of that click listener. And it then registers the click listener, and it will, even after the script completed, then always execute this function, because it stored that in memory and all the surrounding data it needs, whenever the button is clicked. Output result, however, is not executed when the button is clicked, but when the script first executes. So what we do here is we try to write to our page, but we don't do that whenever the button is clicked and therefore when our current result changes, but only when the script initially runs. So the solution is to grab that piece of code and also add it into the add function so that now here we output our result. And now we can also soon start adding a calculation description again. For now, I'll just replace it with the empty string. But the more important thing is that now it uses this current result here and it now outputs that into our web page whenever the add function runs. So if we now save this and I reload and I enter 5 and then I press plus, you see result 0, 5? Let's add a 10 here. This gets stranger and stranger. This is clearly not a valid calculator. So the good thing is we're seeing the output here. So generally our setup with the function and so on seems to work, but we're clearly not doing some mathematically correct calculations here. So what's the problem? The problem is the type of the value we're using here. Current result in the end is a number, right? We start with 0 here. Now what we add to current result here, however, and that's something you just gotta know, which is why I tell you, is a string. Because I'm getting this from this user input, and even though I entered a number here, and even though this user input actually even is of type number here in the HTML code, whatever you get from a user, from an HTML input in your JavaScript code will always be a string. Just something you can memorize. An input element, if you read its value, will give you a string. That's how JavaScript in the browser works. It doesn't try to be smart and check whether that should be a number or not. It doesn't make any assumptions. It just gives you a string, text. And therefore, what happens here is that we have a number and we have some text. And now JavaScript is it has a problem because we're trying to combine a string and a number. And how would it do that? Well, we saw how it does that earlier when we built this calculation description. There, we also combined text with a number because the default result we used there was just a number. And JavaScript concatenated that to one long string. And it's the same here. It got a number and a string. Instead of converting both to a number and doing a calculation, it does the safer thing because it doesn't know whether what you entered here as a string could be treated as a number or not. And it therefore simply converts it to a string and concatenates it to a string. And that's what we see here. We started with an initial value of 0. It concatenated 5. Then we had 0, 5. It added 10. So this is now that one long string which we got. And again, it does so because it doesn't know whether what you entered here can be used as a number or whether it just is some character which it can't use as a number. Therefore, the default is that it builds a string here. Now, of course, we want to build a number here, however. And we know that whatever the user enters here should be a number so that it can be used in mathematical equations. Now, how can we convert this value to a number then to tell JavaScript that we have a number and it should therefore do a mathematical calculation instead of string concatenation? To convert this to a number, you have a function built into the browser or built into JavaScript, a bit like the alert function we used earlier, which is called parse int. You also have parse float. The difference is that parse int will try to parse some text, so a string, as a number without decimal places. And parse float will do the same with decimal places. So with parse float, if you entered 10 here, this will be parsed as 10.0. With parse int, if you entered 10.1 here, which actually this input doesn't allow, but if you would do that, it would give you 10. So parse int and parse float are functions built into JavaScript that will, in the end, take a string as an input, take a string as a parameter you pass in, and will then convert this text into a number. Now, of course, that can fail. If you had some text here, like hi, which again, I can't enter here because this is configured to take a number, but if you would have hi here, parseInt would actually, of course, not be able to convert this to a number. Instead, it would convert it to a special value, which I'll show you later. For now, we know we get valid numbers and therefore we'll be able to parse it. I also only work with non-decimal numbers here, so only with integers as it's called, so numbers without decimal places, and therefore parseInt will work. So now if I save this, we're doing a calculation here with a number and the number, and hence if we reload and I enter 10 here and I then click plus, we see 10 here. And this is now not 0, 10, so not some concatenated string. Instead, if I enter a 5 and I click plus again, I see 15. So this is now a real number. Now, instead of parseInt, you can also use a plus here, by the way. even without parentheses. So we have a plus here, that's the operator. Another plus in front of the string will then also convert the string to a number. So that's the shorter form of doing that conversion. And it's up to you whether you prefer the plus or parse int. Parse int and parse float is of course more explicit about what it's doing. The plus here is easy to overlook. And if you know I want to have a non-decimal number, or I absolutely need a decimal place, well then parse int gives you that extra control. The plus will just give you the best fitting number. So if it's a number without decimal places, it will keep that. If it's a number with decimal places, it will keep that as well. So parse int and parse float also allows you to be more specific about which kind of number you want. Now, if you ever would want to convert a number to a string, you could do this as well by adding dot to string. That's another built-in function tied to the number here, which converts this number to a string. This, however, is definitely used in less cases, I'd say, because more often you need to convert a string value to a number to use it in a calculation than the opposite way around, because as you saw earlier, the default of JavaScript was to concatenate two strings. So we had that default behavior of treating this here, or using this number here, in a string anyways. So with that out of the way, we're doing that conversion correctly, and the add function is working therefore. Now we can still improve this function a little bit, or improve this overall code, and also of course improve the output we're outputting here. So let's work on the output here of our log of the calculation we did, so to say. Here I in the end want to output the last calculation we did. And for that I want to output a string here, and I'll create it with backticks so that I can inject values dynamically with this $ curly brace syntax. Because what I want to output is current result plus, and then the new result. Now, the problem we have with that, of course, is that after this line, our current result already changed. So I rather create this description here, maybe just name it description or calc description or whatever you like, and grab the template literal as it's called and move it up here. And then here I refer to current result before we change it, because I run this line before this line. And I want to add my number here. So I can copy this code and add this here as well. And actually, we of course don't need to parse this as an integer, because I will need it as a text anyways. We're building a text here after all. So I can also just use it like this. Side note, when using this embedding syntax here in a template literal, any values you pass in, even if they're numbers, will be converted to a string anyways. So this implicitly calls toString anyways, you could say. So this is automatically treated as a string here. And now I build my description here and output this as well and reformat the code to use these two blanks here as indentation. And now we're building the description before we run the calculation. And now if I save this and I reload and I enter 5 here, we see the description of the last calculation we performed whenever we run a calculation. We don't see the full log because that would be way more complex to build, a bit beyond what we can do right now, but we see the exact calculation that was just executed that led to this new result. Now, with that, there's however more we can change about this function, because what we're doing here is we have a bit of code repetition. Now, in general, as a programmer, you want to avoid code repetition as good as you can, as much as you can. Because if you repeat code, you write too much and that takes time and you want to save time. And in addition, if you ever need to change something about that piece of code, about that logic you wrote there, chances are that you need to change it in a couple of different places. So therefore, you want to avoid repeating yourselves, so that whenever you need to change that piece of code you wrote, you only need to change it in one place instead of 10 places or something like that. So here, for example, extracting that user input value, let's say we renamed this user input constant here to USR input. Well, then I have to change it in 2 places. USR input, USR input. Of course, that's not too bad, but imagine that this would be a longer script. Would be very annoying. So it's better to then create a new constant, since I never plan on reassigning a value, which I could name user number, or better, maybe entered number. And that could be this code snippet here. So where I get the user input and parse it as an integer. And now we can use entered number here, because that string interpolation or embedding syntax here doesn't care whether that's a string or a number. It will convert it to a string anyways. And we can use it here. And now the advantage of this is that whenever something changes here, like the name of this constant, we only need to change it here and not in these two places. So even though I added a new line of code now, we actually did something good because we're now more flexible and we don't repeat ourselves. Well, of course, we repeat that name of the constant, but that's something we can't change. However, we make sure we don't repeat the entire logic here, even though, of course, that's not too much logic here, but you could have a more complex calculation and you would therefore even save more repetition. You could also take it one step further and add a brand new function. Get user input, for example. Again, I named this function like this because I want to describe what the function does. And this is a function which should actually give me the user input as a number. So we could also name it get user input number or get user number input if you want to be very clear. But in the end, you want to give a clear idea of what this function does. Well, and in there, I want to return this logic here, where I get that user input and parse it as an integer. So that here, I can just call get user number input as a function. So here I now call that manually instead of adding it to an event listener, because whenever this function runs, I want to run this function as well, which I now use to outsource this logic. That's especially great, of course, if you have more code here, multiple lines of logic, for example, that you want to share. You can then all put it into a function and call that function in any place in your code where you want to execute it. Right now, that's only one place, but that will soon change because we got more than one button here. So let's work on the other buttons now. So let's make sure we can also press the other buttons. And for that, the thing we can do is we can add more functions. We can add another function which could be called subtract, because that's what it should do. We can add another function which should in the end multiply values, and a fourth function for this, which is called divide, which does just that. Now we have all these functions, which of course are empty right now. There's nothing in the function body, but they are defined. And now let's add logic. Now the logic is generally the same as in the add function. So I'll copy that and adjust it. I want to get the entered number. And here, by the way, I can reuse that constant name because, as you learned, this constant or any variable or constant which you define inside of a function belongs to this single function. And therefore, you can use the same name in another function because these two are totally detached from each other. This name is now not reused because it's not available outside of the function anyways. Hence, we can use it in multiple functions. So here, I'm also getting the user input. Then here, my description, of course, is different. I want to have a minus here. And the calculation also is different. I want to have my current result, which is calculated with a minus instead of a plus. Now you see, there's still some code repetition we have here, still some code we needed to copy. There are some pieces of code we can't avoid copying or we can't avoid reusing, like here getting access to the number input. We don't necessarily need to store this in a brand new constant. We could use it directly in the places where we need that entered number, like here. But I find it a bit easier to read if we store it in a new constant. But for generating this log text and outputting this, this is actually something we can put into a function to share and reuse the code instead of copying it. So I can add a new function up here. And again, it's just my pattern that I like to use, that I define functions before I use them. So if I use a function down there, I define it above, but that's up to you. The order does not matter, as you learned. So here I'll add a new function, name it create and write log or something like this, which should write that output, or therefore create and write output maybe. And now this function will need 3 operators to work the way I want it to work. I'm interested in the operator that was used in that function, and you can name this however you want. This should be some text which contains the plus, minus, or so on. Not the real operator which we could use because you can't pass an operator as an argument, but we can pass a text which contains the operator so that we can output it. Then I need the result before calculation and the calculation number, let's say, so the number which was used in the calculation. And then I can grab this calc description and create it here. Now the operator is also dynamic, so I'll also embed this and use my operator. And I have my result before calculation and the calc number. These are the 3 pieces which I combine together into one text. So that's text here. It's not a mathematical equation which is executed by JavaScript. It's just some output text which I'm generating here. And thereafter, I'll call output result here. I can refer to the current result because that's a global variable which gets changed. And my calc description, well, that's this constant. And now the idea is that here I can actually run create and write output. The operator here was the plus, and I need that to build that string correctly, which describes the operation which was performed. The result before calc, which is my second parameter that is expected, and the order does matter, of course. So my second parameter here is the result before we ran this calculation. So here, that's current result before we ran it. To store this, I can add a new constant. Initial result maybe, which is current result before we change it. Now, since we copy that value, initial result won't change if we then run this line. That's what I also explained earlier. So now we can pass initial result here. And the calc number, of course, is the entered number here. So now we can use that also down there and get rid of that line with output result and where we build the calc description. And here instead just forward that minus. And yes, we need to copy that initial result code. So still some copied code, but the logic of building that string and of outputting it in our web page, that is outsourced into a new function. And all that refactoring, as this process is called, where we move code around and try to write it in a more elegant way, is totally optional. I just want to get you used to it because it is something you will need in your life, in your day as a programmer, as a developer. You want to write elegant code where you don't repeat yourself and where you then try to split your logic. There rarely is a single right or wrong way of doing it, but getting started with it and thinking about it is always something you should do. So now with that, let's actually copy that logic into multiply. And there we need the star operator. And here in the calculation, of course, also the asterisk here to multiply this. And for dividing, here we need the slash, which is the division operator, and also output this here in our log. And now with that, if we save all of that, we just need to register the event listeners for these buttons. So just as we have an add button in the vendor file, we got a subtract, multiply, and divide button, so we can use these as well. So here I'll add subtract button, and then just copy this code here, but of course point at the subtract function here, and then repeat that, but of course now use the multiply and the divide button here. So multiply and divide button and point at multiply and at divide. Now with that, if we save that and we reload this page, if I add 5 with the plus, 0 plus 5, now enter 3 and then click minus, 5 minus 3, and the calculator now just works such that you need to enter the value and then press the button where you want to use that value with the previous result. That's how this calculator works. That's why it's the unconventional calculator. So now let's add 10 and star. So we had 2, so now it should be 2 times 10, and that's the case. And finally divide by 4 maybe, and we get 5. So this all works. Now we connected a couple of buttons to our functions, and we also had a first look at code refactoring and code reusage, an art which you will master as you work as a developer, and where you shouldn't worry if you're not totally sure how to split your code yet. That is something that comes with experience and something you will also do a lot throughout this course. So by the end of the course, you'll already feel way more confident about that than you probably do right now. Now, we wrote some code already. A feature which you can also use in JavaScript and many other programming languages are comments. You can add comments to your code to make it more understandable to fellow developers, or to yourself if you're coming back to your code after a couple of months of break or something like that. Now, a comment in JavaScript can be added in two ways. You can add it here like you add regular code by adding 2 forward slashes. This is a comment now. This means that this is there for people to read, but it has no effect on your code. If you reload, you don't see an error or anything like that. It's not executed as code. Instead, this is just there to comment your code, to make it more understandable. If you have a longer comment to write, which should be split across multiple lines, you can of course add another line of comments here with 2 other forward slashes. But you can also add a block comment by adding a forward slash and then a star. And now you see everything is green down there because now everything after that is treated as a comment. So this is also a comment, and this is. And now you have to close the comment with a star and another forward slash. So the opposite combination we had here to open it. So now this allows you to write a longer comment across multiple lines without starting every line with 2 forward slashes. Now, how would you use comments in your code? You shouldn't comment the obvious. So if you comment, this is a function that extracts the user input from the input field, that's not the best comment. Because for one, you don't want to write long text. You don't want to write essays here. Instead, you want to write short, to-the-point comments that add some extra context or understanding that isn't obvious from looking at the code. So if I look at this code, it's pretty obvious at what it does. We could just add something like gets input from input field. Why is that useful? Because it adds this extra context that this is coming from an input field, because it might not be obvious by looking at the code that user input refers to an input field. So that could be something we could add to make understanding that code a bit easier and simply save the developer who's looking at the code the time to kind of find out what user input is referring to. Here we could add something like generates and writes calculation log. Again, this might not really be necessary because that's quite easy to see if you look at this, but if you have a first quick look at this, it could look daunting, and then this makes it clear that this is in the end just a helper function that outputs some information and generates that information as well. You can also add a comment in line, so after some code, like here. We could say from vendor file to make it clear that this function is not defined somewhere in this file, but lives in the vendor file. Otherwise, this might not be obvious. And again, if someone wants to follow our code or understand it, this could help with understanding it. So adding such a short inline comment also sometimes can be useful. In general, you want to comment your code, especially if you share it with others, but you don't want to overdo it. Don't add redundant information. Don't write too long comments, because then people will not read them at all and they actually get less out of them than if there were no comments at all. And you don't want to comment the obvious. Instead, provide some extra context, extra information that can help understand your code faster, or briefly share your thoughts regarding the code you wrote here. That's something you could add with comments. We got quite a nice application going here, at least for the basics into which we're diving. Now I want to dig deeper into some of the core JavaScript features you gotta know, because you will need them in many of the projects or the applications you're going to create with JavaScript. And one important feature, if you want to call it like this, is a special set of operators, which you can also use in your JavaScript code. Now we already saw the assign operator, the plus, the minus, the multiplication, and the division operator. We used those. Now there are a couple of shortcut operators, if you want to call them like that. For example here, what we're doing, and not just for adding, but also for subtracting and so on, what we're doing is always we're assigning a new value to current result, and that new value is based on the current or the old value of current result, plus or minus and so on, a number. Now, if you have a calculation like this, which is quite common, there is a shortcut. You can absolutely write it like this, but if you assign the result to the same variable you're using on the right side of the equal sign, you can omit that variable there on the right side, omit the operator, and instead write plus equal. So instead of a single equal sign, use plus equal. And that's exactly the same as having, in this case here, current result equal to current result plus. So you can remove that from the right side and add a plus here. And as you will see, if I now save this and I reload this, if I enter a 5 here and I click plus, that still works as before. So that did not change, that still works, but now we have a shorter code snippet here. We have less code which we have to write. Now the same is available for all the other operators. So instead of this code here with the minus, we can also write minus equal, and the same for the multiplication and division. So we can take this, multiply this here, and also remove that division code here and use this shortcut. And with that, if we save that, you'll see that now as I reload this, we can add, we can subtract, we can multiply, and we can also divide. This all works now with this shorter code thanks to these shortcuts. Now there also are other shortcuts or other shorthand operators, as they're also sometimes called. If you have, let's say, the case that you want to set a new value to a variable, let's say to current result, and that is the current value plus 1. So exactly plus 1, which we of course don't need here, but imagine we had that case. Then instead of writing this, you can also write current result plus plus. The same is available for minus. You can write current result minus minus. It's not available for multiplication or division, because what would that be? Multiply the number with 1? Well, that's the same number, and the same for division, right? But adding 1 or subtracting 1, that makes sense. And with this increment or decrement operator, as it's called, that is possible in a very short way. So if we do that here, and I comment out this line for the moment, this, by the way, is a common pattern that you use comments to temporarily remove some code, which you then can re-add later. But since comments are ignored, you can kind of temporarily remove code by commenting it out, as it's called. So if we do that, and we therefore only reduce current result by 1, if we click add, you will see that now if I don't enter anything here, because I'm not using the value anyways right now, if I add a plus, you have a result of minus 1. We can ignore this NaN thing for now. Here, the result is the thing that matters. So this gets lower and lower, always by 1, each time I click the plus button, because we're decrementing this here. A little side note, you could also write minus minus or plus plus in front of the variable, and it will actually have a small impact or a small difference. Not if you just use it like this to change the value, but if you're interested in the return type of this operation, if you add plus plus in front of this, it will actually edit the current result by adding 1, just as it does if you add it thereafter. If you have plus plus or minus minus in front of this variable, then this operation returns the edited value. If you have it after the variable, well then this returns the value of the variable before it was changed. Now here we're not using the return value, but if we would alert that return value, it still changes current result always in the same way by adding 1, but this operation returns a new value which you can or cannot use, depending on whether you want to use it. So here, for example, I'm using it by outputting it with the alert, and if we do that, and I reload here, you see I get 1 here, so I get the result after the change. If I add the pluses at the end here, and I repeat here, save this and reload, then I get it before the change. So this plus plus and minus minus operator returns something. It returns the value before or after the change, depending on where you add the pluses and minuses. Again, in many cases that doesn't matter because the variable itself is always edited in the same way. It just makes a difference regarding the value which is returned. Now, of course, here I'm not interested in incrementing this, so I'll just remove that line and comment this back in. By the way, in case you're wondering how I did this so quickly, I used a shortcut here in my IDE. Under Edit, you can use toggle line comment to, well, add or remove a comment to quickly comment code in or out. So these are some additional operators which I recommend that you keep in mind, and that therefore completes our list of operators which we are aware of for now with these shorthand operators and the increment and decrement operator. Those extra operators which you have are good to know because sometimes you can save some extra code by using these shorthands, these abbreviations. Even more important than that, however, are other data types you can work with. We learned about numbers, where you have numbers with or without decimal places. Numbers without decimal places are also called integers. Numbers with decimal places are also called floats. Besides numbers and text, or strings as it's called, you also got other core data types which you have to know when working with JavaScript. For example, there are booleans. Now, booleans are a bit strange and a bit hard to understand right now because they really shine once we learn about control structures, if statements, which we'll do in a separate module soon. Booleans are effectively values which have one of two possible values, true or false. So where you can, as a number, have any number, or as a string, have any combination of characters, Booleans are exactly one of two values, true or false. Now, you might wonder when you need such a restricted data type. And the answer is quite often, because quite often in code, you have some condition, like is the user currently logged in, which is either true or false. And then you want to run different code based on that condition maybe. And that's what I meant. Booleans shine if you have conditional code, and we haven't really learned about this yet, but we will learn about this in a whole module as it's such a core feature. So already keep Booleans in mind. We'll dive deeper into them a bit later, and then very deeply though. More important, and something we will see right away, are objects. Objects are an extremely important type in JavaScript, maybe the most important type if you would have to choose one. Of course, you need all of them, but objects are really important. Objects allow you to group data, you could say. Something like this. Now you create an object with curly braces, and of course we already saw curly braces when we wrote a function, and that of course was not an object, that was the function body. But without the function keyword and so on, in the place where you could also use a number or a text, you can create an object by adding curly braces, and then you have key value pairs in there. Now, as I said, you used it for grouping or relating data. Let's say you have a little program where you work with persons, where you have user data that you kind of need in your JavaScript code. Now, each user might have a name and an age. Of course, you could have standalone separated variables for that, but having an object makes it much easier to understand that this data kind of belongs together, that it's related, that you use it as one piece of information, if you will. And therefore, objects are really powerful. You can also do way more with them than just group data, and we will do way more with them throughout the course. But the data grouping functionality on its own is already pretty amazing and very important. Now, and speaking of kind of organized or grouped data, another core data type are arrays. Now, arrays are created like this with the square brackets here, also in the same place where you would create numbers or text or whatever you need. And an array is simply a list of data. So arrays are always great if you need to store a list of data, let's say a list of transactions, a list of maybe calculations in our calculator. And you can store any data in there. It can be an array of integers, so of numbers without decimal places, like in this example, but it could be an array of text, an array of floats, an array of objects, even an array of arrays is possible, and you can also mix data in there. You can have an array that has numbers and text elements and so on. Elements in an array are separated by commas, as are the key value pairs in objects. But I'd say it makes way more sense to understand and explore these objects and arrays by simply working with them. So let's do that in the scope of our project. How could we introduce arrays and objects here? Well, let's say we want to log every operation we do. So when we add, when we subtract, when we multiply, we kind of want to log this. We want to store this in an internal log, which we theoretically could send to a server or anything like that. In Node.js, we could write it to a file. In the browser, we can't because we don't have access to the file system there for security reasons. But we might want to keep track of that, right? Because we want to store it on our own analytics server, for example. Now, in such a case, we want to keep track of a list of operations because we're not just interested in the first click on the add button, but we want to store every click on every button, and therefore we need to have a list of data that gets bigger and bigger over time. For that, we can add a new global variable here, and I will create it here with the let keyword and name it log entries. The name is totally up to you, of course. Again, it should be a name that kind of gives an idea of which kind of data you're going to store. And it's a plural name here because I'll have multiple elements in there, because it should be such an, well, array, as I mentioned. Now you create an array by adding square brackets, and it can either be an empty array or of course an array with some initial data, and there each element is separated from the other elements by a comma. Typically you also add a white space to improve readability, but that's not required. The comma, however, is required. Now here I want to have an empty array though, because initially we have no log entries, and therefore we can create it just like this. Now if we want to add a log entry, let's say when we click the add button here, we could say we go down there, and now we want to edit this array and add a new entry. Now, how can we do that? Well, we can refer to log entries, and now previously we always assigned a new value by setting this equal to a new value. Now, of course, we can set it equal to a new value here as well, and here the new value would be a new array, because I want to overwrite the existing empty array, and therefore, of course, we could also leave this uninitialized, with a new array, which now includes, let's say, the entered number, right? So now we set this to a new array, a new list of data with one element, and that one element is this entered number which we have. Now that's one way of editing an array. We basically overwrite the array stored in the variable with a brand new array, and sometimes that's just what you need, but sometimes you also want to edit the existing one. And for that, let's reinitialize this to an empty array up there. Let's say we want to add a new element to this existing array. For that, we can reach out to this array and not assign a new value with the equal sign, but instead use a dot to use a function that belongs to the array, so to say. And there's a specific function built into JavaScript, and that's the push function. Now, actually, arrays have way more than just a push function, and I have a whole module dedicated to arrays where we dive way deeper into them. For now, let's focus on the push function. The push function does what the name implies. It pushes a new element onto this array. So it adds a new element to the list. And there we could say that should be the entered number. Now, it would be kind of neat to see that array. And for now, we can do something which you will often do during development. You can add console.log here, and that's a built-in functionality built into JavaScript, a built-in command which the browser understands, which allows you to output something into that development console, into the console which you see in the developer tools, where we previously saw some errors. Now here we're not outputting an error, but an information log message. And here we can, for example, log the log entries, so the value that's currently in that variable, which should be that array with one extra element if we run this for the first time. And after the second click, it should have 2 elements because we always push a new one. Let's see. Let's save that. Open the developer tools in your browser and go to the console there. Reload the page. And now enter any number you want and click on the plus. And of course you see the result down there, but more interesting than that, you see this thing on the right here. That is your array. And if I add another value, so if I click the plus again, you see now, this is the new log. This now is a new array, or the old array with an extra element to be precise. You see we have 2 elements in there separated by commas, in this case 2 numbers, but again, you could store any data in the array, and therefore that's what we have in there. And this is a great way of keeping track of multiple items, multiple pieces of data that are kind of belonging together and that should be managed as a list of data. Now, if you want to read from the array, in the sense of not logging it entirely, but let's say you want to extract the first element that's in there, so the 5 in this case, well then you can also do that. If you want to access a specific element in the array, you do this by adding square brackets after the variable name if you access the variable. So in a place where you want to get or read the variable, you can also add square brackets thereafter. And now in there, you add the index, so the position, so to say, of the element you want to extract. Now you could think that you add 1 here if you want to read the first value, but this will actually not work. Because that's just something you have to know, but thankfully it's the case in pretty much all programming languages, or in most programming languages, arrays are 0-based, or their index is 0-based, which means the first element in an array has an index of 0. So if you want to access specifically the first element, you want to retrieve that to work with it, then you do this with this square bracket notation and then with index 0. Index 1 would refer to the second element, index 2 to the third, well, and so on, and index 0 therefore to the first one. That's just how it works in many programming languages. So now what we should see when we log this is that we don't log the entire array, but a single value of the array, to be precise, always the first element in the array. So if I now reload this and now I add, let's say 6 here, you see I log 6, not as an array, so without the square brackets, but just a number, because that's what we're retrieving. And retrieving, by the way, does not mean that we destroy the array. It's still there, it's still managed in memory. I'm just reading a single value from there, because that's also something you need quite often in programming, that you have a list of data, but then for a specific operation, you want to work with one specific entry of that list. And again, as so often, we'll of course also see examples for that throughout the course. So that's how you can add a new element to an array. By the way, if you would try to read the second element, so the one with index 1 here, we would actually get an error here in this code, because when I reload this, when I add a new element here, you see I now get undefined, so not an error technically, but also not the value we expected. Because of course this already fires for the first element we added, so when I clicked the button for the first time, and there we simply have no second element in the array yet, because we only added 1 value, so we pushed 1 value into the array, so there only is 1 value in there, and as you learned, that 1 value has the index of 0. Only after the second button click, we have 2 values in there, and then we can retrieve a value with index 1, which is the second element. So now if I add another element here, now this gets logged. And if I add a third one, I of course still get 11 logged here, because I still extract the second element, and that's still the element we added on the second click. So that's arrays. We can manage lists of data with them. There's way more we can do with them than just push and access single elements. But again, that's also something we'll gradually learn throughout the course, because we also need some other things, some other pieces of knowledge before we can fully unleash their power. They're already quite nice like this though, to manage lists of data. So that's arrays. What about objects? As I mentioned, objects are great for grouping data together. And you create objects with the curly braces here, and then you can have multiple key value pairs separated by commas in them. So let's create an object. Let's say we don't just want to add the number which we added to our log, but a more detailed log information package, if you will. Because the number alone, of course, doesn't tell us much. It would be interesting to log the result before we added the number, the operation itself, so that we can add items to the log, not just here, but on all these functions, and we can then just attach the information, whether that was an addition or a subtraction operation. And therefore, we need a more complex piece of data that we manage in the list. This is a great scenario for objects, because now we need to manage multiple pieces of data that are kind of related. And these pieces of data then, in turn, are managed as a list of these pieces of data, because we have multiple such actions. So here we could add a new constant, let's say, because I never plan on editing this, which I'll name log entry, and this should hold such an object, which you, as you learned, create by adding opening and closing curly braces. Now, of course, we also use curly braces here for creating the function, but that's different. Here, we used it after the function keyword, after the name of the function, and the list of parameters. This is a pattern JavaScript detects, which tells it, well, these curly braces should now hold the function body. On the other end here, we have no function keyword and nothing like that. Therefore, this tells JavaScript, since it's on the right side of an equal sign, where you always define the values for something, for a variable or for whatever you're working with, this tells JavaScript, okay, you want to create an object. Now you can create an object like this, an empty object, but that's not too useful, arguably. Now what you can do instead, of course, is you can add key value pairs. So pairs of identifiers and values which you store in these identifiers. Now often you will write an object across multiple lines. That's not required. You can do it all in one line just for readability's sake. Often you split it across multiple lines, and then you can also, of course, indent to make it more readable. And here you could, for example, add let's say operation key. The key names are totally up to you. You could name this op or operation or whatever you want, and then separated with a colon, you add the value. Now values can be anything, can be strings, numbers, arrays, or other objects. You can also have objects in objects. So here as an operation, I'll store a string which says add. So this is kind of my identifier, you could say, that when we see that log entry later in the output, we see, okay, that was an operation where we added two numbers. Now, of course, I then also want to store these two numbers. So I have my, let's say, number 1, or my previous result, so the result before the operation. You can again use any key name you want here. And then again separated with a colon, the value. Here the value of course should be a number, and it should be my initial result to be precise, because that is my result before we performed this operation and we added the number. Now we also of course need the value which we added. So we could name this number or operand. So kind of the value we added to the previous result. I'll name it number. And here again, separated by a colon, we now set a value to this identifier. And here that would be my entered number, because that is the number I added to the previous result. And maybe we also want to add the result after the operation here in our log entry. So that could be the result or new result or whatever you want to name it. And here I would simply use current result, because we changed current result here, which means 2 lines after that, it's still that changed current result, and therefore I want to add it here to my log entry. Now it's the log entry which I push here onto the log entries array, so that log entry object, and then here I want to log the entire array to my console. If we do this and I reformat my code to use 2 blanks here, 2 white spaces for indentation, if we do that and I now reload, let me again enter any number here, click plus, and now you see here we have an array, and this is just shortened in the developer tools. If I click this arrow, it's expanded. An array with index 1, so with the first element at this index being an object, as you can see, and if we expand this, we see the full object. We see in that object we have a number key with a value of 66, the operation key with a value of add, which is a string, here logged with double quotes because that does not reflect the quotes we used necessarily. Both are available interchangeably, and the developer tools here simply use double quotes. The previous result, and which was 0, and the new result after the operation. And if I add another element here, I get a new array. If we expand this, we see that new element. And if I expand this, we see our second operation where the number was 2, which is correct. It was still an add operation. Before we had a result of 66, and now we added 68. So this is how we can create and use objects. Now, before we use it everywhere, let me show you how you can extract information from such an object, because that's also something you sometimes need to do. So we're adding our log entries to the log entries array, which is great. Now let's say for some reason, maybe in another part of your code, or maybe here, you need some data from your log entry. You don't need the full object, but you need the operation. And here, let's just say we want to log it. Of course, it's kind of redundant here because we know what operation we added here, but it's just so that I can show you how you can access data on objects. And you do this with a notation, which we already saw. You use the name of the object, log entry here, and then you use the dot notation. You add a dot here, and a dot tells JavaScript that on the object in front of the dot, so log entry here, you want to access one of the properties, as it's also called. So one of the data pieces that belongs to the object. And here you see my IDE already gives me this auto completion. You can also get this by pressing Control and space. And I can then access operation, for example, and by outputting log entry dot operation. If I now reload this here and I add a 5 here, you see add gets printed here, and that's just that data piece I'm accessing here with this line of code. So the dot notation allows you to access data in objects. These key value pairs here, or the keys here, are also named properties. So you access a property here with the dot notation and then the name of the property or name of the key, whatever you want to name it. And of course, it's also something we saw before. It's also what we in the end use down there when we call add event listener on our buttons. There we also use the dot notation, and then the only interesting thing is that here I'm not accessing a property which contains some data I can read, but that I actually access some function. Because you can also have functions in objects. But that's something we'll dive into in the objects module, where we dive way deeper into objects. For now, let's just think about them as groups of data, of key value pairs, where your values can be strings, numbers, arrays, other objects, and so on, where you can either hard code data like I'm doing it here, or point at variables, and then the value of the variable will be stored here as a value for this key. And that's it for now. Objects are really powerful, and we'll see them many times throughout this course. There's so much you can do with them. For now, let's just use it like this though. And let's now also make sure that we actually are able to add log entries, not just when we add two numbers, but also when we subtract and so on. So it would be nice to generate similar log entries for subtraction, multiplication, and so on. And of course, that means we can grab that code here and copy that over to subtract, use subtract here as an identifier, and that actually is all we need to adjust. But again, that means we're duplicating code here. Now we already have one thing in common in all these functions here. We call create and write output. Now why don't we create a similar function for creating our log? So I'll add a new function here where I say write to log, and this expects to get the, let's say, operation identifier or whatever you want to call it, the previous result, the operation number if you want to call it like this, so the number we used in the operation, and the new result. Now these are very long names here, and to make this easier to read, I'll now actually also split this in multiple lines With the code formatting shortcut, my IDE actually does this automatically. You can do that without issues. JavaScript understands this. You can write multi-line code. You have commas between your arguments here, and therefore JavaScript is able to understand where your function parameter list starts, here with the opening parentheses, and where it ends. And you can write this across multiple lines. It's not a must do, but I'd say it's a bit easier to read. So that's my write-to-log function, which gets all these arguments. Now in the function body, I in the end want to do what I did here. So I'll cut that code from add and add it here, create the log entry. And now, of course, all the values I use here are the values I'm getting here as parameters. So for operation, I use my operation identifier. So this argument I'm getting here. For previous result, I use previous result. So here I have the same name for the argument I'm getting as for the key I'm using in the object. You can do that, you can avoid it if you prefer. It won't clash because, of course, these are two totally different places where you use it. So here JavaScript knows that this here on the left side of the colon is an identifier in the newly created object, and it would never look for a variable of that name because you can't use a variable here. And on the right side, it knows it needs a value, so it looks for a valid value, and that could be something hard-coded, like some string you enter in place, or it could be a variable that holds a value. So here, JavaScript will look for a variable, or in this case, for a parameter, which is like a variable, and therefore it will take that variable's or that argument's value. For number, I want to use operation number, and for result, of course, new result. And now this is added, and I also log this. And now we just need to call write-to-log and provide all these pieces of information, so these 4 arguments. So here in add, we can call write-to-log like this. And now the identifier could be add. Then our previous result, and my IDE here gives me some auto-completion support to tell me which value for which parameter I now need to enter. So here for previous result, that would be the initial result variable value which I have stored here, so that this is provided to the function. For the operation number, that would be the entered number which I want to pass into the write-to-log function. And for the new result, that would be, well, current result at this point of time, right? Because we change it here, so 2 lines thereafter, it's still the same result, and therefore I pass this to the write-to-log function. And now we can copy that and call that here in subtract as well. Leave everything as it is, but change the identifier. And do the same here for multiply. So here I'll add multiply as an identifier. And of course, do the same here for the division and add divide as an identifier. And now we're reusing this write-to-log function to create our log object with different dynamic data which we add in, which we get as parameters in the function, which we then use to build that object, which we then add to our array, which we then log to the console. So let's give that a try. Let's save that and reload. And now deduct 5. So we have -5 here. We have an entry in the array. We see the operation was subtract. Previous result was 0. Number now is 5 or was 5. Result is -5. If I try to multiply this with 7, got a new entry in the array. This one is it. Previous result -5, number 7. We multiplied it, so the new result is -35. And now if I divide this by, let's say, 2, got a new output here. Divide, number is 2, previous result is -35, result is, therefore the new result is therefore half of that, -17.5. So that all seems to work. We're able to log it, we're able to reuse that logic, and we're able to do this basic work with our JavaScript object here. With arrays, booleans, objects, numbers, and strings, we had a look at the most important, or almost all of the most important data types you have in JavaScript. Now there are 2 additional important data types and one strange value which looks like a data type. And that would be null, undefined, and NaN. Now what's that? So these are kind of special values, though null and undefined are both values and data types. So what's the idea behind that? Undefined is the default value uninitialized variables have. So if you create a variable and you don't assign a value at the beginning with the equal sign, then this variable is undefined. We also saw undefined in the log when we tried to access an element in the array at an index where no element was created yet. Then we tried to access an element which wasn't there, and therefore we got back a value of undefined. So that's a value. It's a value that indicates that nothing's there. But at the same time, it's also a separate data type. So just like numbers and strings are a data type, undefined is also a data type actually. Now, you should never assign undefined to a value on your own, so never write equals undefined, because that's just a default value you have if something has never been assigned a value. Now, you could have cases in your code where you indeed get something where you're not sure if it's undefined or not, and later you will learn how you can check whether a value is defined or undefined, but it's already important to be aware of this type. Now, related to this, there's the null value and type. Now, it's very similar to undefined. It means that there is no data, but undefined is the default value for variables and so on, where you never assigned a new value. Null is never a default value on the other hand. Instead, you have to set something to null to use that value. And that's often used if you want to reset or clear a variable. Let's say you have some user input and you want to reset this. You could set it to an empty string, but you could also set it to null, for example, to make it clear in your program that there currently shouldn't be a value because no value has been entered or whatever. And again, this is especially useful later if we can also run some checks, some conditional checks with if statements to find out if a value is set and then do something, or if it's not set. So undefined and null are important to manage empty data, either because it never was set or because you want to set it to empty to null. They're very similar, but they're not entirely equal because of the reasons I explained. Now, there also is one other special value, and that's NaN. That stands for not a number. And technically, unlike undefined and null, which also are their own types, this is not a type. Instead, it's of type number. It's not its own type. And you can therefore use it in calculations where you work with numbers. Now, the idea behind NaN is that it's kind of like an error code if you run a calculation with something that doesn't include a number. So if you have, let's say, a multiplication with text or anything like that, then you would get not a number as a result. And if you use the not a number value in a calculation, you also get not a number as a result. So this yields not a number if you use it in calculations, and it's the result of calculations that are invalid. Now you might wonder why you would ever run an invalid calculation. Keep in mind that JavaScript allows you to write highly dynamic code. So, like in the case of our calculator here, you could have a calculator where users can enter any value, where they are maybe not forced to enter a number, and where therefore you could run a calculation with some user input, which is not a number, and then you could get such a not a number result. Again, this is most useful if you also have the abilities of comparing it or of checking it with some if statement to run some code if you get such an invalid result, but it is worth being aware of this type. Now, to quickly give you an idea of these types, let's clear that JavaScript console here, because here we also can type some JavaScript code which runs immediately, which is immediately evaluated. And here I want to show you these three types I just talked about. Let's create a variable here, username maybe, and not set this equal to anything, just like this. So we declare it, but we don't initialize it. If you now hit enter, you see undefined here, because that's the return value of this execution here. But if you now write console.log username, or actually here in the console, you can just write username and it will automatically log it to the console, you see the value that's in there, and that's also undefined. Now, of course, if I now assign a value like max, and I print this, you see, well, max here. It also showed it here. So that's one thing. We got undefined if we haven't set this to a value yet. Now, if you would want to reset this, as I mentioned, you should never do this. Technically, this would work, but this is not recommended. Instead, you should set this to null now, this other special value. And if you do that, and you have a look into username now, you see this indeed is null. Now for the not a number example, if you run 3 times hi here, you see the result is not a number. If you run 3 times not a number, which is also a special value written like this, you also get not a number. So these are the special types which for now you should just keep in memory somewhere, and which we'll come back to throughout the course when we'll be able to check for whether a variable has a value or not. For now, just loosely keep these values in mind. Now that we had a thorough look at these basic and very important types you can use in JavaScript, these types of data, I want to show you a little keyword, which you can use in your code here, of course, as well. And that's the TypeOf keyword. The TypeOf keyword lets you evaluate the type of a variable at runtime. Now we could use it here, but to quickly see the result, I'll just do it here in this console. You use it by typing TypeOf, and then the name of the variable which you want to evaluate, or of course just the hard-coded value like this string here. So here, if I run this, you see I get back a string which contains the name of the type I used. So here it's a string with the name string in it, and indeed that is the case here, right? That is a string. Now of course we could also use our username variable which we initialized earlier, set this to max, and check type of username here, and would also get string, right? So we can also use a variable here, and you'll get the type of the value that's stored in the variable. Now we can of course also check the type of a number, and you see it is number then. It's a string which simply contains the description of the type, so in this case number, or the name of the type, so in this case number. And that's the same no matter if we use an integer as here, or a floating point number as we do here. We also can check type of true. Now we haven't really worked with true or false yet, but these are these booleans I mentioned, and hence of course it prints boolean here. We can also check the type of an array, like this. And you see here we actually get object, and that's interesting. An array is a very important feature. Very technically though, it's of type object. So there is no special array type. It's a special type of object, if you will, but the overall type is just object. So thus far we saw string, number, boolean, and now object. Now unsurprisingly, if I check the type of an object, which I create with curly braces here, I also see object being logged here. So they are of the same type. An array is just a special type of object, you could say. Now, if we check undefined, we see, as I mentioned, that this has its own type, undefined. On the other hand, null is also just of type object. So it also has a type, a special type, which is not the same as undefined, but it's not type null, but instead type object. So another special kind of object, if you will. If you, on the other hand, check not a number, written like this, we see it's of type number. So this is not an object, this is not undefined, this is not its own type, this is a number instead. So TypeOf, quite nice here to get an understanding of which kind of data you're working with. Of course, we'll see all these different types of data in action throughout this course and all the examples where we need to work with numbers, with strings, with arrays, with objects, and so much more. Now, to conclude this module, let's come back to something we actually started the module with. And that's how we import our scripts into the HTML file. I'm doing this here at the end of the body tag, at the end of the body section in the document, and I'm doing it here because our scripts rely on the HTML page being rendered. We are accessing items in the page, so to say, in the vendor file, where I establish connections to the buttons and so on, to which I then add event listeners here in the app.js file. And in order to establish these connections, we need to run the scripts after the browser parsed and rendered all the HTML code. Otherwise, the buttons to which we want to establish connections simply don't exist. So that's why I import the scripts down there. Now, this is still not entirely optimal, and let me show you why. For this, open your page here in a new incognito window here in Chrome, And I simply use this incognito window here because this allows me to rule out that what I'm about to show you gets distorted by any extensions or browser plugins. So I opened the page here in Chrome in the incognito window, and now we can again open the developer tools, which allow us to have a look behind the scenes. And there I increased them in size a little bit, and there you should go to this performance tab. You can also click these arrows here if you don't find it here. Now, what's the performance tab? The performance tab allows us to get an idea of what the browser does in detail when it renders this page. And there are many things you can do with it, but it's a great tool for understanding how the scripts are loaded, parsed, and executed, and what might be the issue here. So with the page being used here, press this record button here, and then reload the page by using a shortcut for it or using the reload button, and then stop recording this. Now you get this profile, and this might look confusing at first. I'm only interested in a short part of this timeline. Now in this topmost window, you can select a part by holding the mouse button and dragging, and I'm interested in this part where we have these little hills down there, you could say, where you have these vertical lines. Now if you select this, it gets zoomed in here in the middle and bottommost window, and there you see which network requests were sent and what the browser did, so what it parsed, what it executed, and so on. Now what we can see relatively quickly is that we have one long-going network request which downloads the fonts. This kind of distorts everything here, so let me comment out this link here, which does load the fonts, to not have this distraction in here so that we can focus entirely on the scripts. So comment this out in the HTML file so that this is no longer getting used, save the file thereafter, and then let's repeat that, let's clear this, press the record button, reload this page, stop recording this, zoom in here. Now we have a clearer picture of what happened. What happened is that here in the network tab, we first download the index.html file, that's the blue part, and thereafter the CSS file and the script files. Now let's go to the bottommost window. There we see what the browser did in detail. And if we zoom in here, which you can do with the mouse wheel, you see that in the end here, we receive a data. That's the downloaded HTML file. If you see, this roughly lines up here in the network tab. It's done downloading the file. That's when this receive data event is triggered, when it finished loading it. And then it starts parsing the HTML code. Now it starts parsing the HTML code, and what you can see is that pretty much at the end of that, when it's done parsing this, it sends off requests to the JavaScript files. The CSS file is sent off relatively early. If you would draw a vertical line down there, that happens early when that gets parsed, which makes sense because we request the CSS file here in the head section. But the JavaScript files get requested a bit later because we request them at the bottom of our HTML file. Now obviously that's not a huge file, so there's not much time difference between, but still we request the JavaScript files only after the parsing is done, or when it's almost done entirely, because we do that at the bottom of the HTML file. So that's why we only request the files once we're almost done parsing the HTML document, as you can see with this vertical line. Now what's the implication of that? Of course, the benefit is that the scripts only execute after parsing is done, but we also see that we start parsing, and only when we're done, we download the scripts, and only once the scripts are downloaded, way over here, of course, that's not that long if we have a look at the milliseconds, I'm only talking about a few milliseconds here, but still, only after this is done, we actually execute the scripts. These are these yellow blocks you find down there. These are the two scripts which are getting executed. The other parts are the style sheet being parsed and the styles being rendered. We can ignore that. So here we execute the scripts. Now what we effectively see is that we start executing the first script at around 930 milliseconds, and we're done parsing at around 906, 907. So there are roughly around 20 milliseconds of pause between us being done with parsing the HTML file and executing the script. Now, these are all very small numbers which we can't even feel when we load the page, because we have small scripts and we have a small, short HTML file. But imagine that our scripts would be longer, that they would take longer to load and execute, and that we have way more HTML code that needs to be parsed. then it's not that great that we wait for all this code to be parsed just to start loading the scripts. We certainly want to execute them after this was parsed because we rely on the parsed content, so that's fine. We don't want to execute the scripts earlier, but loading them earlier, downloading them from the server earlier, that would be a good idea. Also keep in mind that all the loading is very fast here, of course, because we're doing this all locally. We're just accessing the file here. There is no web server involved. There is no latency. So this would be slower if we were really serving this web page. And hence we have the ideal scenario here, and yet we have this unnecessary delay, and we certainly want to shrink that delay if we think about really hosting this on a web server. We don't want to start loading the scripts once everything was parsed. We want to load the scripts as early as possible and then still only execute them after everything was parsed. So we want to get the best of both worlds. Now, of course, we can grab the scripts and move them in the head section, maybe here below the style sheet. Now, if we do that, and I clear this, start recording and reload and stop, we get a better picture here. If I zoom in, here we download the HTML file, and now what we see is that we start parsing HTML. Now, we then fetch the styles and the scripts, and we pause parsing here. As you can see, we pause that. We only pick it up back here when basically downloading the scripts finished. We also executed the scripts here. Now, this looks a bit strange. It looks like we downloaded app.js for longer than it actually took because we do execute it here. So this is a bit distorted. The main takeaway here is that we start parsing HTML, then we encounter these script imports, we then download the scripts and pause parsing, therefore, this blocks parsing, and then we execute the scripts, and only thereafter we continue parsing. Now that's of course bad, and this also causes an error, because now we try to interact with the buttons on the web page without those being ready, so that's also not ideal. We download the scripts earlier, which is great, but we now also execute them too early. The solution is an extra attribute which we can add to the scripts, and that's the defer attribute. You add it like this, without a special value, just like this, to both script tags, and defer tells the browser that it should download these scripts right away, but that it should not block parsing HTML, so that it instead should continue with parsing HTML, and only execute the scripts after everything has been parsed. So it starts downloading early, but it doesn't execute the scripts right away once they finish downloading. Instead, it guarantees us that it only executes the scripts once they were downloaded and once parsing HTML finished. So if we now save this, we go back, clear this again and create a new snapshot, reload, stop. If we now zoom in here, we see HTML file is downloaded, we start parsing it, and then here what happens is that I download all the scripts and I execute the scripts over there, the two yellow blocks here, but parsing HTML did finish before that. This is the entire HTML document being parsed. This blue block here is the style sheet. This is not HTML, and these are just some events in between these small blue blocks. So now the script downloading and execution doesn't block the HTML code from being parsed and rendered. Instead, that continues. And the only thing that does change is that we download the scripts earlier, which is great. Now again, in this scenario here, that's all a bit hard to really see because it's all so super fast because I serve it locally and we have very small files. But the general concept and the difference should be clear. And of course, this matters way more if you really serve this on a server and if you have bigger files. And you can see that all this parsing and script execution is done roughly 20 milliseconds after we started parsing the HTML document. So that is faster than what we saw previously when we started loading and then executing the scripts at the bottom of the body tag. So therefore, what you should do when working with JavaScript is you should import it like this in your head section with the defer attribute, because this ensures that it gets loaded early but executed only once parsing HTML finished. So you have the best of both worlds. Now, sometimes you also have scripts which you want to load early, but which you then also want to execute early, because maybe they don't rely on the HTML code. You don't establish a connection to it, and therefore you don't care whether parsing HTML finished or not. This can also be achieved by using the async keyword instead of the defer keyword. Async works a bit like defer. It tells the browser to start loading the scripts as early as possible, and then the browser is not blocked but instead continues parsing HTML. But the difference to defer is that with async, the script then executes right away once it was downloaded. So it does not wait for all the HTML code to be parsed. Instead, it executes as early as possible. So then parsing of HTML will be paused until this is executed, and only thereafter it will pick up again. Here, therefore, this is not the correct solution, because that could lead to the script being executed before all HTML code has been parsed. But in other scenarios where your scripts don't interact with the web page because you maybe just send some data to some background server, well, in such cases you could use async. One other important difference to be aware of is that with async, a script really executes as early as possible, so as soon as it was downloaded. The order of the script execution is therefore not guaranteed. The app.js script could execute before the vendor.js script if it is loaded earlier. With defer, on the other side, the browser guarantees the order. So even if app.js would be downloaded faster, vendor.js would still execute before app.js. So the order is guaranteed with defer, it's not with async. So async is really just a solution if you have a standalone script that doesn't rely on your HTML content. Also note that defer and async are only available if you have an external script. If you have an inline script, so a script which you write right in here in your HTML file, if you have something like this, defer and async is ignored, because what would that do? There is no file to download. This is embedded in the HTML file, so this is available once the HTML file was downloaded. So therefore, defer and async doesn't make sense here, because there is nothing that would need to be downloaded. Such scripts are always executed immediately, and therefore if those scripts which you embed here rely on the HTML code, you always have to move them to the end of the body section. But in general, it's not a good idea to have important or longer scripts here in your HTML file. You should always use external files for that, to keep your HTML file small and focused, and don't bloat it with a lot of scripts. Also important, you can't combine an inline script like this and then an import with the source attribute. If you do that, then the inline script will be ignored and just the external file will be imported. So you can't combine that. Now with that, let me remove that and turn this back to defer, because that's now our final setup. And if I now save this and I close the developer tools and I reload here, and I also comment back in my font because now I want to have it back. If I do that, you see this still works as before, but now it does so with the help of scripts that are loaded in a more efficient way, which does not make a big difference for this simple application, for this simple demo here, but which does matter or could matter a lot for bigger applications which you really host on a web server. This is it for this module. This was a crucial module where you learned a lot about the basics of JavaScript. You learned about variables and constants, which you create with let and const, about the differences between declaring a variable or constant with let or const, and initializing by assigning a value with the equal sign. You learned about operators like the equal sign to assign a value to a variable, or the plus and minus operator, multiplication, these shorthand operators, and also the increment and decrement operators, if you remember. You learned about functions, which allow you to define code that can execute multiple times whenever you call the function, or also, as we're doing it here, whenever you click somewhere or whenever some event occurs, for example, which is something we'll also dive way deeper into later throughout this course, because we'll work a lot with the web page and events and so on there. You learned about how to manage data in general, how to pass data into functions, how to work with parameters you receive in functions, how to write proper code, how to use the right syntax, how to work with numbers and strings, how to work with objects, and how to work with arrays, which are lists of data. You also learned how to import your scripts properly, which is of course important because you want to optimize such things as well to ship the best possible experience to your users. And with all of that, you have a solid foundation for the next chapters in this course. We're still only getting started. There's so much more we can learn, but it's super important that these basics are set. So really make sure that all these concepts are clear. Also use the additional resources you find in this section, the attached resources, the text lectures where I also clarify and summarize things, where you can also come back to if something is unclear at a later point of time or if you forget something. And with that, let's move on and dive deeper into some core features which you need in pretty much any JavaScript application you're going to build. Now, with our first steps taken and with some core basics out of the way which we need in any JavaScript program, before we dive deeper into more basic features and more syntax and language features you need to know, let's have a look at debugging your code and at ensuring that you're able to efficiently work on your code, that you're efficiently developing. Because that is important. When you're writing code, you will encounter errors. And therefore, in this module, we'll have a look at how you find errors, how you fix them, which different tools you have, and which different kinds of errors you might be encountering. Now, in addition to that, it's of course also important that even if you're not facing errors, you're productive. And that means that you leverage the IDE or the editor you're working with, and that you're getting a lot out of it, that you're feeling comfortable writing code with the tools you're working with, and that overall you have a smooth workflow and you're able to progress and to write good code. And that also includes, and that's the last thing we'll also have a look at in this module, it also includes that you're able to find help and to know resources where you can dive deeper, where you can learn more. So these will be the blocks we'll have a look at in this module. I already outlined it in the introduction video. There are effectively 3 parts that we'll have a look at in this course module. The first part I want to have a look at is how you can write code efficiently. And with that, I don't necessarily mean that you can write code as quickly as possible, but I mean that you're able to really get a lot out of the tools you're working with, that you know how to write code without too much copy and pasting or manual work. Now, the next block we'll then have a look at is how you can find help. Because in programming, even if you took many courses, even if you've been a developer for many years, you'll always encounter scenarios or use cases where you're not sure how to solve something, or where you know there was a feature in JavaScript, some built-in function that allows me to do that, but I can't remember that function. I don't recall how it worked in detail. And that's totally normal. When becoming a developer, the goal is not to learn all features and all the commands by heart. That will be impossible, not only because there are a lot of commands to learn, but also because programming languages evolve and new features are being added. So don't take this course or any other resource as a I have to learn it by heart resource. Rather learn how a language generally works and how you have to think about writing code, and then also know where to find help and where to dive deeper if you need a specific feature or a specific command. And that's also something I'll explore with you in this module. And the last block is that you need to be able to debug your code. You will encounter errors, and therefore it is important for you to be able to find and fix these errors. So if we talk about writing code efficiently, what exactly does that mean? It means that you should work in a productive environment. And with that, I'm talking about the environment on your machine, not the environment you're working in. Of course, that should also be productive, but that's something you'll have to figure out, where you work, in which office, and you might also not be able to control this if you, for example, are employed. So I'm talking about the IDE, the editor, and about configuring it such that you like working with it. That also includes that you use the editor or the IDE to its fullest potential, that you're able to auto-format your code so that you don't manually have to indent things and so on, that you use important shortcuts. It also, of course, means that you take advantage of the auto-completion and the hints many editors and IDEs give you. Visual Studio Code, the IDE I recommend for this course, certainly does so. And of course, it also means that you keep your eyes open for editor extensions and for the settings you can tweak there to really adjust everything in the way you like to have it. So let's have a look at that, and let's explore some of the things I would recommend that you look into and that you get started with. Here is the app we've been working on in the last course module opened in Visual Studio Code. Now that's the editor, the IDE, we've been using throughout this course, and I showed how to set it up and how to basically configure it in the first course module, so definitely make sure you watch that. Well, I guess otherwise the last module was a bit hard to follow along anyways. Now, this editor is configured to suit my needs, and I recommended some basic configuration which I like because I don't think I have that much of a special taste. Still, make sure you tweak this to your likings. And that starts with the look. In Visual Studio Code, and of course in most or in all editors and IDEs, you will find similar settings. You are able to adjust its appearance. In Visual Studio Code, you do that under Code, Preferences, and then, for example, here, the color theme. The color theme is the core thing that influences how the editor looks like. And a lot of people prefer the dark look I have here, in my case with the dark plus default dark theme. But you can also go for a light theme if you're a fan of this, or choose one of the many other installed themes you find there. You can also install additional themes with the help of the extensions section, which I'll dive into in a second. So the theme here is the first thing with which it all starts. Now, besides the general theme, you can also set a file icon theme here in Visual Studio Code. And there I installed the material icon theme with you in course module 1. You can, of course, also go with one of the built-in themes or install any other theme you want, either with this shortcut here, but this will also just lead you to the extensions marketplace, if you want to call it like this, and we'll have a look at that in a second. So the look, of course, should really suit your needs. It's also not just the theme and the icons. Also make sure that here in the view section, you configure the appearance the way you want it to look. That you show the sidebar or the status bar, maybe show one of the other things you can show here, like that activity panel here, which I personally don't like to have, which is why I remove it here. So really play around with these settings and find a layout that you like, that works for you, that allows you to be productive. Now, of course, the look and feel of your editor and your IDE is one thing, but it doesn't stop there. Once you start writing code, there are also other things that really matter. For example, that you are aware of some key shortcuts. Now again, here in Visual Studio Code, you can find many shortcuts by just going into the different sections here that allow you to edit your code, and there you always find the shortcut that would allow you to do the same thing. These are simple things like undoing or redoing, which you'll use a lot, or copy and pasting, which you probably know. But then we also got things like here, toggling the comments, which I did already in an earlier module, which allows you to quickly comment a line in or out. And the shortcuts you're seeing here might not be the same ones I have here, because you can rebind these shortcuts, and I'll come back to that in a second. Also important are the selection shortcuts you find here, or the selection modes you find here. This allows you to quickly select similar values, for example, with the add next occurrence shortcut if you want. There I could mark log entries, and if I now hit the shortcut for this, or I choose the option here of course, but using the shortcut is simply faster. So if I do this, then it selects the next occurrence of this same word, if you will, in my code. So now I have this selected and this selected. And that's great for renaming, for example. If I want to rename this, I can just hit the shortcut until I have all occurrences selected. I also get a hint here on the right in the scroll bar where all these occurrences are. And then I can give this a new name, and now it's renamed in all the places where I did use it. So that allows you to change and refactor things much faster. And this is also a crucial shortcut. And all these selection shortcuts can be really helpful. For example, for moving something up a line or down a line. That makes restructuring your code, which you will ultimately do a lot in development, way easier. Now, not all shortcuts might work for you. Maybe you want to change one, and you can do that under Code, Preferences, and then there Keyboard Shortcuts. If you click on that, you find all the shortcuts which are built in, and there are a lot of shortcuts. But the good thing is, it's really great to search this. For example, if you're not happy with that Add Next Occurrence shortcut here, and you want to use a different one, well, you can type Add Next, and it's actually this one here. You can also search for a key binding. If you can't find the shortcut otherwise, you can search for this here on Mac by just typing Command D. And now it shows you all shortcuts that include the Command key and the D key. Of course, also the Control or the Shift key is supported. Same for space and so on. So you can also search for keys and find the actions that are bound to these keys. So that gives you a lot of power to really find all the different commands you might need. And then, of course, it's needless to say that you can change them by just right-clicking on this and then change key binding. So really make sure that you adjust these shortcuts to your requirements and that you simply have a look at the menu up there, the menus up here, to find some actions that might look useful to you and bind these to shortcuts which you can reach. And as you work and as you grow as a developer, you'll find more and more shortcuts you work with. So the goal is not to stop developing for 2 days now and just explore all possible shortcuts. You can do that if you like, but my recommendation would be that you just have a brief look at the options you find here in the menu and experiment with these options. And then as you continue with development and as you write code, you will automatically reach situations where you think, that would be really nice if I could fix it with a shortcut. And then you can go to this shortcut changing menu, to the keyboard shortcuts menu here, and simply search for the action you want to do and see which shortcut this has. And if it doesn't have a shortcut yet, you can assign one. So using shortcuts, really something which I would recommend. Now, all the shortcuts don't help you if you write bad or incorrect code. But here again, modern IDEs or editors like Visual Studio Code have you covered. You get a lot of auto-completion here. Let's say here, with our create and write output method. If I want to use this method, let's say I would want to call it here, I can type create and write, or just create in my case, and I get suggestions. I get suggestions of functions or variables that I could use here that basically include the word create. And they don't just have to start with it, they include it anywhere. It doesn't even have to be one word, as you can see with the suggestions down there. All properties or functions that include the characters I just typed in the right order will be shown here. And then the suggestions are narrowed down the more I type. So that's really useful because that allows you to write code quicker. For example, here I can just type create. The IDE intelligently guesses that I probably mean create and write output. Otherwise, I could select a different option. And then all you have to do is tap enter or tab to use that and to complete that word, which of course saves you the hassle of writing it all on your own. So that's much faster. Now, in addition, you also find a short description of what you're going to use here on the right. Here, for example, you see that this is a function, that is the name, and that this function will take a couple of arguments, which of course allows you to find out if that is the function you really want to use here. Some functions and properties, especially the built-in ones, even have short descriptions attached to them, which you then also find here in the panel on the right to learn more about it and learn more about what this will do for you. So this is very important and really helpful. You also get something similar if you, for example, add a dot after an object, or in this case here after an array, which turns out to be an object. If you add a dot here, you get this auto-completion that offers you a list of all the properties or functions you can access on this object, like the push function here, which allows us to add a new entry. Then you get a short description of it here on the right. You see the arguments it takes. The syntax might not fully be clear at this point, but that's not a problem. We'll dive more into arrays later. And you see that an array, for example, has way more methods or way more functions attached to it. And I'll dive into way more of them in a separate module focused on arrays. So this dot notation also comes with great auto-completion. And by the way, if this menu ever closes or you accidentally close it, if you want to bring it back, of course you can delete the dot and add another one. But you can also just use a shortcut, which by default should be Control Space, and this will bring up this suggestions menu again. So this is another core feature which I would recommend that you use. You can also hover over things, and you'll get a short description of what this is and what this does. For example, that push is a function. It's called method here, and I'll come back to what the difference is, but it's essentially a function, and you see what it does. So this is also helpful. You can hover over things to learn a bit more about it. And when you call a function, like let's say, create and write output, and you enter the parentheses, you by default get this parameter help here, where you see all parameters, and the value which you now need to provide for the first parameter is even highlighted here, so that you know that whatever you're going to type now will be received on this operator parameter. And once you enter this and you add a comma, you see that now the next parameter is highlighted. Now that's really convenient. If you ever close this menu for some reason, you also get a shortcut for this. So let's quickly check this and maybe just type parameter here. What we see is we got this trigger parameter hint shortcut, which is this combination, Shift Command Space in my case. So if I now type Shift Command Space here, you see this menu reopens. So that's also really convenient. So these are the core features you should be aware of and you should experiment with and you should leverage, because that helps you write correct code faster and without errors. And that's always something you want to do, of course. Now, last but not least, many modern IDEs and editors allow you to install extensions. Here in Visual Studio Code, you reach that extensions section by going to View and then Extensions. The default view which we're currently in is the Explorer, by the way. Now, if we go to extensions, what we see here is a list of enabled extensions I got installed. Got a couple of Angular extensions here because I work with Angular, and then a special theme which I installed, Dart, because I did some Flutter and Dart development, and a couple of other extensions as well. Now, you can, of course, always search for extensions by typing up here or by scrolling through the recommended ones. And for example, what you could do here is you could search for Prettier. It's one extension which we got installed already. We installed that in Module 1. Prettier is an extension that helps you with auto formatting. And in my case, as I said, I already have it installed. But if you don't have it installed yet, you can install it from here. Now, you can always learn more about extension on this page. You'll learn how it works, how to use it, how to configure it, which settings you can adjust. And this, therefore, allows you to tweak the development experience to your requirements and maybe even add brand new features to your development environment. So definitely also utilize this. My recommendation just would be that you don't install too many extensions, because it's easy to add more and more and more extensions. And at some point of time, your editor might become slow because of all these extensions, or you get strange behaviors, maybe strange auto formatting, which you didn't expect because you got multiple extensions clashing with each other, or extension A changing some configuration of extension B. So don't overdo it, but of course have a look at potential extensions that might help you. With that, let me go back to the Explorer. Now, as I mentioned, extensions can be installed and also can be configured. And in general, dive into your settings. Here in Visual Studio Code, you do this with Code Preferences Settings. There's a lot you can configure. For example, if I search for tab width here, I can configure how much white space is entered when I hit the tab key. Here you see what Prettier, the extension I installed, will use for indentation, and that are 2 blanks, which I want to use in this course. But you see that, for example, my editor by default would use 4. So I'll change this to 2 here as well. And if you do that, you can always choose whether you want to save this for your user, which means that will be the setting in all projects you open with Visual Studio Code, or in your workspace, which would only be this project. If you choose workspace, so if I change this here, and you save that, that will actually be written to this settings.json file, which you find in the .vs Code folder, which is then automatically created. There you find your project exclusive settings, whereas your general settings, which you set up for the entire user, are not stored in this project, but unsurprisingly are stored in a global place on your machine, so that Visual Studio Code uses them no matter which project you're working in. Now here you also got a bunch of settings. There are so many settings you can scroll through to configure the text editor exactly to your requirements, to change the font you use there, the font size, the way it looks, the way it behaves. There's so much you can do here. Now attached you find some resources that help you dive deeper into Visual Studio Code if you're using that, and in general feel free to just browse through that. Normally, the default should be pretty good, but if there is something you want to change, something you detect which you would like to behave or look differently, then there's a good chance that you can change it here in the settings. Under extensions, you also can change the settings of the extensions you installed, for example, of Prettier. So if you got an extension and it doesn't behave the way you want it to behave, maybe you can adjust that in the settings here as well. So also explore that. Now last but not least, in Visual Studio Code, under View, you also got these different modes here. I showed you the extensions view, which allows you to browse extensions. Explorer is that view you see here, which is the view you typically work in the most. It allows you to see your files here on the left. Search can also be very helpful though. Search allows you to search through all your files, and you can change how it searches. For example, if it searches in a case-sensitive way here. And there I could search for write to log, and if I do that, it shows me that it found this write to log thing in 5 places, all in app.js, and if I click on there, it highlights it here. It also highlights all the results here in the scroll bar on the right. So this can also be very helpful. Now under view you also have the SCM view. Now that helps you with source control. So when you're using Git, then you see what you changed since your last commit, and you can inspect what you changed here and commit that and so on. So if you want to have a graphical user interface for source control, you can use this. And debug is a mode I'll come back to later in this module once we dive into debugging our code. This can be really helpful with understanding our code, how it executes, and can help us find and fix errors. So that's Visual Studio Code and working with the IDE, and I hope it gave you a general idea of what you can configure there, what you might want to think about, and what you might want to explore to work with your code effectively. So you're able to work with the IDE in an efficient way. Now you also need to understand where to find help, where to dive deeper in cases where the IDE doesn't provide sufficient support. And there we got one amazing resource for web development in general, but also specifically for JavaScript. And that's MDN. I'll come back to MDN in a second. It's a web page. It's like the official JavaScript documentation if there were one. There you find everything about JavaScript. It's extremely detailed. You find information about basically every built-in function and object and thing you can do, and it's an amazing reference. Can be overwhelming if you first dive into it, but I'll show you how to work with it in this module. Now, in addition, you need to learn how to Google. Seriously. It's astonishing to see how many developers are not able to Google. Often in development, you don't know the solution yet, or you just know, I want to do this, maybe I can do it like that, but I'm not sure. And then why don't you just Google it? But of course you need to know how to Google, and I'll show you in this module, to find discussions where other people discussed the same issue, and where you then maybe find some ideas on how to think about the problem or how to solve it. Also, learn how to ask proper questions, no matter if you're doing that here in the Q&A section or in public forums like Stack Overflow, which is a great developer forum. There you can ask for help, but you need to ask in a way that allows others to help, which means you need to describe your problem. If you're getting an error, you need to copy and paste in the error message. You really need to ask proper questions to get proper responses. And also help others. Don't just ask, also help others. Be friendly, dive into the community, because that will allow you to grow as a developer. And last but not least, no matter how seasoned you are as a developer, you will always have a lot of trial and error. Sometimes you know how you want to solve something, you know that it should work the way you're writing your code, but it just doesn't work. Well, don't give up then. Just keep on trying. Tweak your code. Google, come back, change something, and find a fix, find a solution. Of course, here I'm not talking about syntax errors, simple errors, where you misspelled something, but where you just can't get the logic right for something, where you want to calculate a random number between 1 and 10, and you always get one between 0 and 1, let's say. Well, this is all about trial and error, tweaking your code, trying out if it works, and that is also an important part of development. So let's dive a bit deeper into all of this, and let's start with MDN. You can just Google for MDN, and here we're already getting started with the Googling, and you should find the MDN web docs. Now, in case you're wondering, MDN stands for Mozilla Developer Network, but this site evolved over time, and now it's not just a site maintained by Mozilla, but instead a lot of developers are working on it to make it the kind of pseudo-official web development reference and guide collection. Now, on this page here, you can dive into different technologies, for example, JavaScript. And there you'll also find a couple of tutorials, which I really can only recommend that you also dive into. They won't replace this course here because these are all written tutorials, so you find no video tutorials in there. It's more about reading here, and it can be overwhelming if you're brand new, in my experience, but it's a great additional resource also to go through at the same time whilst you're going through this course or after going through this course. So this is really amazing. There you can learn a lot about JavaScript, its core features, its core functions that are built in, all the syntax, and so on. And then you also got the references and the guides. And there you also find more tutorials, but for example, under references, you find detailed references for HTML, CSS, and JavaScript. And if we explore the JavaScript one here by clicking on reference, what we actually can find there are complete references of all built-in objects. And you see there are a lot, no worries. We'll learn about all the important ones throughout this course. You can find more about expressions and operators which are built in, all about functions, how to write them, how to configure them, and so on. So you really find a lot of stuff in there which will help you work with JavaScript and write good code. So this is a great resource to come back to. And often it's easiest to work with it by not just searching on their site, but let's say you want to learn more about the parseInt method. Well, you can always search for MDN and then the thing you want to learn more about. For example, parseInt. And if you do that, you should find the parseInt article on MDN, as I do here. And there you see a short snippet for it, a short description. You can even run that short snippet. You then find the detailed syntax description below, the arguments, the parameters this takes, and what needs to be passed in there. You find a more detailed description, more examples. So that's really, really amazing. And by the way, if you dive into this right now, it can be overwhelming because there you also see some features covered which we haven't covered yet in this course. But still, to look things up, especially if you're a bit further into JavaScript development, that can be really helpful. And that's what I meant with don't learn it by heart. It's all written down there. You just need to remember that there was some parseInt function and you can search for it and find it here. Now, what if you don't remember the exact name of something and you still want to learn more about it? Well, let's say we don't know that it's called parseInt. Then, Googling this correctly would be that you type JavaScript to kind of narrow down what you're interested in this case, the JavaScript language, and then convert string to number. And if we do that, then here automatically even Google gives us a hint that parseInt probably is helpful. But we also find more. If we scroll down, here we got parseInt already. We also will find something on Stack Overflow, which is the kind of official development forum where you find a lot of discussions. You can also ask questions on your own here, but many problems have already been solved and can be found here. And therefore you can find solutions here by just Googling correctly. Here you find one suggestion with this number thing, which we haven't seen. But then here you also find parseInt again. Or this plus operator, which I already showed you in this course as well. So that's really helpful, and this is what I mean with Googling correctly. First, put JavaScript so that Google only shows you results that are kind of related to that. And then try to describe the problem you're having with only a couple of keywords. Don't write sentences here which you would speak to another human, but instead use keywords, important keywords that narrow down your issue. And this normally helps you find discussions where that problem has been discussed, or give you a link to MDN or comparable sites right away. So this is also how you should think about solving problems here and about finding help. So you know how to write your code and how to dive into external resources and find support. Now you're writing code and you're having errors in there, and that will happen. That doesn't make you a bad developer, that's just totally normal. You will always also encounter errors when writing code. Now we need to learn how to find and fix them, and that there also are different kinds of errors. So when we think about debugging our code, there are different kinds of errors you can get. You got errors which basically show you some error message where your app may be crashed, where it doesn't work at all. And you got logical errors. Logical errors don't make your app crash. They also don't result in an error message, but your app behaves incorrectly. Now I will show you both kinds of errors in this module and show you how to find and fix both. Now, if you're getting an error message, read and utilize it. Seriously. So many people see an error message and they just go into panic mode and that's it. So many people don't even bother reading error messages, even though many error messages are quite clear regarding what's wrong. So by just reading it and diving into the line of code, which typically is included there, you can fix many errors. If you got an error message which you don't understand, you can Google it, because guess what? You're probably not the first person who got an error message. So put it into Google and you'll find many solutions there. But sometimes that alone doesn't do the trick. Sometimes you need to look into your code whilst it's executing to get a feeling for how values of variables change over time and where something might be going into a wrong direction. For that, you can use console.log, which I already showed you. This is a built-in command which outputs information in this developer tools console. It's invisible to the users of your page unless they open the developer tools, then they can see it, and that's important to keep in mind. Everyone can see what you output here, not just you, but it doesn't show up on the page itself. And it allows you to log whatever you want, log whichever variable you want to log. And this can be really useful for getting a first look into certain things or values of your code. You can also have multiple console log statements to see how things change throughout your program execution. So to kind of output the flow of your application. But writing these console log statements can also be cumbersome. Especially if you have a more complex error to fix, you might need to throw a lot of console log statements into your code, change them, configure them correctly, and that can be annoying over time. So therefore, also leverage the debugging tools which are built into modern browsers. I recommend the Chrome debugging tools, which are really amazing, but Firefox also has debugging tools built in, for example. Same for Edge and so on. But in this course, I will go with Chrome and show you how to work with those. And last but not least, your IDE can also help you with debugging and with fixing errors. We'll have a look at all these things now in the next lectures. Now let's start with errors which you can typically avoid. For example, simple syntax errors. Let's say you simply forgot to close your array here. Now right away, the IDE yells at us basically. You see we got the red squiggly line here. I got a red mark here on the right in the scroll bar. And the file itself also turned red. Here on the left in the Explorer, it's now red. And this indicates that there is something wrong, which the IDE detected right away. You can then always hover over the red squiggly lines to get a description of the problem, and here you see expression or comma expected. Now, to be honest, that's not the best error message because it doesn't really describe the problem here, that a closing square bracket is missing. Nonetheless, you quickly see that something is wrong here, and trivial errors like this, of course, can be easily fixed because you should quickly see that, yeah, we got a missing square bracket here. Now, that might sound dumb, but it's easy to mistype or to accidentally delete something, and therefore having a look at what your IDE tells you is really a great idea and something you should do. Now, sometimes you also got errors which don't really show up here in the IDE. For example, if I try to call parse here like this is not a built-in function actually, and the IDE knows that it's not built into JavaScript, but maybe it's a function defined by us, maybe in another file. Therefore, the IDE here doesn't yell at me because it doesn't know whether I might have defined a function called parse in another file. For example, here I'm also calling outputresult, which is not defined in this file, and which also is not a default JavaScript function, but since I have it defined in vendor.js, this will work. So it would be bad if the IDE would complain about this line. It's the same here now. Now, of course, this is not built in though, but maybe I mistyped and therefore used this, or I had a function named parse in the past, I deleted it and forgot to update this code. So this is code which works in the IDE, but it will not work here. If I reload this page and I try to add, you see, no matter how hard I press my buttons, nothing happens here. In such a case, it's always a great idea to open the developer tools, and my recommendation would be that you do this in incognito mode so that no browser extensions you might have installed can interfere here, because they might also change something on the page or run some scripts which might show up in your developer tools even though they're not directly related to your code. So open the developer tools here under View, Developer, Developer Tools, or with the shortcut you see there. And there you should always go to the console first, because it's here where you'll find potential error messages. And indeed, here you see I got error messages regarding parse not being defined. Now that's the part I meant with reading the error messages. I could now go into panic mode because there's so much red here, but if we just have a look at the error message, it's pretty clear what the problem is. Parse is not defined, okay. And we even see where this was called. It was called in the getUserNumberInput function, which we find in app.js, and there, this is the line number 7. The error also is stemming from line number 7. And then, if that is not helpful to us, we see that it was called in getUserNumberInput, which in turn happened because this add event here on our button basically triggered. And that was set up in line number 33. Now we can even click here, and we're taken right to the source code here in the developer tools. So here under the sources tab, we now see the problematic source code. And since this is the code as it was executed by the browser, so at runtime, the browser knows that indeed here parse is not defined. The IDE can't know that because it doesn't know which scripts we might be loading, potentially from other servers and so on. But the browser totally knows what's available at this point of time, and it knows there is no built-in parse function, and there also is no code written by me or by some other third party which I added that would add a parse function. Therefore, the browser knows parse does not exist. And now we can have a look at our code and analyze what went wrong here. Did we expect to write a parse function on our own? Well, maybe we should do so now. Maybe we have a parse function, but it's called parse input and we therefore need to rename it. Or, as it's the case here, we're looking for the parse in function. So this is how we can narrow down the issue and fix it with the help of the error message we're getting. So we got syntax errors, which we can typically fix right in the IDE. Other runtime errors, which we can fix with the help of error messages by looking at them. Now let's have a look at logical errors, which are a bit harder to find. Let's say in my application here, when we add, then we're getting the user number input here, right? So that's triggering this function. And there, let's say we're not doing that int parsing. We're not converting this to a number. Of course, we're doing it here, but let's say we're not at this point yet. We forgot to add this code. That would be a typical logical error. Everything will work technically, but the app will not behave the way it should because we have a logical error in our code. Because now if I go back and I reload this page, and I go back to the console here, you see if I enter a 5 here, we got this output which we saw and fixed in the last course module, right? Where the text is kind of concatenated instead of being calculated as a number. Now, we got no error message here, so that's hard. So what can we do in such a case? Well, we can get started with some good old console.log debugging. We know that the behavior is not correct when I click the plus button, so we could go to that add function here, which is the function getting triggered when we click the plus button. And there we could throw in a console.log statement. Now let's console.log the entered number here. And let's maybe also console.log the current result. And you can console.log multiple values here in one and the same console.log statement. You can also combine this with some text. For example, here I'll output input. And this will simply print this text next to these values here so that if you have multiple console.log statements, you can find this quicker. Okay, so with that added, let's go back. Let's reload here, enter 5, hit plus. We see input, then we see 5, and then we see 0. And this doesn't make it super obvious the way it's printed here, but we can see that 5 and 0 look different, right? Even though both should be numbers. The 0 is blue and looks more numberish, if you will. The 5 is black, just like the input text. So if you're really having a closer look here, you can already spot the problem, which of course is that 5 is treated as a string and 0 is treated as a number, and therefore, as you learned, this will be concatenated to a string instead of combined as a number or added as a number. But it's still a bit hard to spot it here, but you can get there with console.log debugging. You can also have multiple console.log statements in your code to understand the flow of your code. If you're not sure if something is executed in the right order, you could throw in multiple dummy console.log statements to see if they are executed in the right order. Now, as I said, we can fix this error here with console.log, but we might not be able to spot the problem just yet. In such a case, you can use the Chrome Devtools, and there go to the Sources tab, where you essentially find all the files Chrome loaded for displaying this web page. So here you find your HTML file, but then you basically find the same folder structure I have, because that's the folder structure that was loaded for this web page. And you can go into the scripts folder, and there you find the 2 scripts that make up this web page. And here we can go into the app.js file and find the exact same code I wrote here, because that is the code that was loaded by the browser. And now here, you can do something neat. You can place breakpoints. Now, what are breakpoints? Breakpoints allow you to tell the browser to stop code execution when a certain part in the code is reached. So for example, here we can go to the add function and place a breakpoint right here so that we stop code execution when we reach this line, so that we can then look into our code and its current state during execution. That's what we'll be able to do. Now, to place a breakpoint, you just need to click on the line number here and you see this mark. You can also place multiple breakpoints, by the way. Now, if you placed that, what will happen is that if you now run your code, in this case, when I add 10, you see now this gets frozen. You see this message here, paused in debugger. You can resume by clicking this play button, but let's not do that now. And here on the right, you see this line now gets highlighted in blue, which means this is where the code execution stopped. And now you can, for example, hover over things to see their current values. For example, since code execution always stops before this line where you placed the breakpoint is executed, you see that entered number is currently undefined. Makes sense, because as I mentioned, it stops before this is executed. So this is all undefined. Now you can step through your code with these controls down there. You can always resume, which means that it will continue running until it hits the next breakpoint if there is any. You can step over the next function call, which basically means you move to the next line. I'll show this later. You can also step into a function call. That would be nice here, because here we are calling a function, and by stepping into it, you see we now jump to that code which is executed in that function. And now here again, I can hover over this. Here, since user input refers to an element in my HTML page, I even get it highlighted on the left, which is another convenience feature. And here, since user input is a quite complex object, I can even find all the properties of this object and get the value that's in there, also by hovering over the value. And we see this is a string, 10. This might already allow us to fix this error at this point, but let's say we haven't fixed it yet. So we see that's a string, okay. We're now done. We can now step out of the current function, back to the code where we had our breakpoint, and we're now in the next line, and we now see entered number is that string. Now we're not interested in this line, so we can just go to the next line with step over next function call or this button. The difference is that this will always step over the next line, and if a function is executed there, it will not go into that function, but just call that function and go to the next line with the result of that function call available. This, on the other hand, will always go to the next step, and if that's inside of a function, it will go into that function. So it kind of combines this button and this button. And we can go through our code with these buttons, therefore. You also see I got this nice output shown by the developer tools here, which shows me the values of entered number and initial result even without hovering over them. And that, for example, should already allow us to kind of fix the problem here, because now we see this is a string, and this might allow us to see that that might be the problem with our addition, that we're working with a string here. If I go over this line, we see current result is this concatenated string, and now it should definitely be clear that the problem is that we're kind of working with strings here. This would probably allow us to fix the error. Now, before we fix it though, let me show you what else we got here in the debugging view. At the bottom, for example, I haven't really talked about that besides these buttons. You see your call stack. The call stack is essentially a list of all the functions that have been called. Let's say here we go into create and write output. If I do that, you see now this is on the call stack as well. And below that is the add function. You can also click here to jump between the lines that are connected. What this means is that the topmost thing is always the function which is currently running, and below that you find other functions that were responsible for calling that function. So that kind of shows you the order of your code execution, if you will. There you also see the variables that are available, local variables and global variables. There, by the way, we have a lot of dummy variables because in the browser we got a bunch of general information about the window available globally. But that's also something I'll dive in later. Local variables here would be the variables available in this function here, and that are essentially all the different parameters I'm getting and calc description. And we can ignore this thing here for now. So that can also be really nice that you see which variables are available there and which values they currently have. You can even change the values here. For example, here we could change this to a number and change initial result to a number to see whether this now executes correctly. And if it does, we would see that the problem is not our addition logic, but the logic where we get the input. So changing these values here is also something useful you can do. You can also set up a watcher here. There you can add an expression where you want to watch certain values. You can either just enter the value name, like entered number, and now you always see the value of this variable here as it changes throughout your function execution. But you can also add a more complex expression like entered number plus current result. And now you will always see the result of this as your code executes. So this can also be really nice for keeping track of how things change during your code execution. Now, needless to say that all of that is lost and cleared when you reload the page or when you're done with the function execution. So this is really just temporarily there in memory to help you debug your code. So that were normal breakpoints and how we use the debugger here. Now there also are other breakpoints, which I want to show you before we ultimately fix this error here. For example, you got conditional breakpoints. Let's say you have some error which you noticed only occurs if you enter numbers greater than 100 here. So let me resume this here. I cleared the breakpoint by just clicking on it again. And now, of course, our error here doesn't occur just for numbers greater than 100, but let's assume that would be the case. In such cases, if you right-click here, you can also add a conditional breakpoint, which allows you to write an expression like only pause here if get user number input is greater than 99. So now we would only pause here if a number greater than 99 is entered. So therefore here, if I enter 100, you now see this pauses here. On the other hand, if I resume and I enter 5 here, this doesn't pause. So conditional breakpoints can be nice, and also very nice if we increase this at the bottom again, are the event listener breakpoints. Now we know something goes wrong when we click the plus button. It also will go wrong on any other button though, so we might not be interested in manually adding breakpoints here to add and subtract and to multiply. Instead, we might be interested in just pausing the code whenever a click happens. And you can do that with the event listener breakpoints. There, you can expand mouse, and there, click. If you click this, if you check this, now you will pause whenever a click occurs. For example, if I click here, now execution pauses in the first line of the function which is handling that click. And now we can navigate through that here. So now you see that pauses no matter where I click. Now important, it does not pause if I click anywhere else on the document, really only on event listeners I registered for click events. There it will pause. So let me clear this now because we don't need it anymore. We already found the error, but that's all important to be aware of. So now that we're able to find the error, let's fix it. Let's say we think we know what the problem is, but we're not sure yet. Of course, we can always go back to our code and change it here and reload the page and try it again. But you can also change your code here in the Sources tab. There we have the suspicion that fetching our user input is the problem, so that this is a string instead of a number. So we could add parse int here, like this, to see whether that does the trick. Now you just have to save this by pressing Command or Control Save, so that the star disappears up there. And you get a warning that this only was saved locally, so only here in the browser, not to your file system. So the code we have here still is untouched. If you go to get user number input here, you see that's untouched. So you don't change your local code, but you change it here in the browser so that you can test changes here in the browser without facing the danger of changing your real code and maybe breaking things there. So now if I add 5 again, now this is looking better because now you see this is not getting concatenated, but instead this really changes here at the end. It really adds 5 as a number. So now that we validated this fix, we can just take it and bring it to our real code and then apply it here, save, and now reload. And now we have the code we wrote, and now we see this is now really working the way it should. So this is how we can work with the debugging tools. Now you got more tabs up there. We'll explore them later in the course. For example, the Elements tab once we work more with the DOM. And the Performance and Memory tab, these are tabs I'll dive in later once we optimize performance and memory usage of our application. For now, the Sources tab, Breakpoints, and the console here. These are your bread and butter tools for finding and fixing errors. Now, the Chrome developer tools are pretty amazing, and as you saw, you can do a lot there, and I personally prefer working with those, but you can actually also use your IDE to set breakpoints and so on. Now for that, here in Visual Studio Code, you just need to make sure that you got a special extension installed, and for that you can search for Chrome Debug, and you should find the debugger for a Chrome extension, which I have installed. If you haven't, make sure you do install it, because this will allow you to connect your Visual Studio Code editor to the Chrome debugging tools. So with that installed, let me go back to the Explorer view here. Let's say we have the same problem we had before. So we want to debug this here. And now we want to be able to run this code with the help of the Chrome debugger, but also connected to our editor here, so that we can set breakpoints here. And we can indeed set breakpoints here. Let's say we have the suspicion that something goes wrong when we click the add button and this function executes. Now you can set a breakpoint here by clicking on the left of the line number, and now we got the red dot here, which means this is a breakpoint. Now we just need to run this application, this website here, with the help of our editor. So instead of manually opening the browser and opening our index.html file in there, now we need to go to debug here and then start debugging. Now, the first time you click this, you might be asked in which environment to run, though this probably is only the case if you got other environments installed, so it might also just automatically pick Chrome if you don't have other environments. Otherwise, choose Chrome here. And now it adds such a launch JSON file in VS Code. This configures how it launches your application in the browser, because it will open up a new browser window. Now, here, this is generally okay, but this URL is wrong. This would be right if you had a local development server, which we don't have here, so that will not work for us here. I'll dive into local development servers later. For now, we should just copy and paste this URL, which we opened in the browser, and basically paste this in here, using the file protocol and then the path to your index.html file ultimately. With that, if you save that, the rest can stay as it is. You can now press debug, start debugging again. And what this will do is it will now launch the app here, enter this debugging view here, which you can always switch with view, go back to the Explorer, or go back to the debugging view, which we have here. And we can also go back to our code now, have the breakpoint set here, and go to that window which it opened, which in my case is this browser window. Now, if I now enter something here and I click plus, you see it goes back to the editor and pauses the code execution here. Now, just as in the Chrome development tools, here we also see which variables are available in this execution context, local and global variables. We can add watch expressions here, just as I showed it to you in the Chrome developer tools. We see the call stack, and we see it's getting paused here. We can hover over things to see their result. And we also get controls to step into a function, for example, and see the updated call stack, see values if we hover over them, and of course step out of them, resume execution, stop debugging and close the debugger with this red square, and so on. So you can essentially do the same as in the Chrome debugger, but now directly in your IDE, which you might or might not find more convenient. Now, I, as I said, personally like the Chrome debugging tools, also because some of the extra features we have here, that we can change the code without really changing the code, but that's up to you. If you like to use your local editor, this is how easy you can get started with Visual Studio Code. Now, you can always clear breakpoints here by just clicking on them again. So this is how you can leverage the IDE for that, in case you prefer that. And once you stop debugging, by the way, which you do by pressing the red square here, this will automatically close the browser window which it opened for you. You can also start the app in non-debugging mode here if you prefer to do that, but you can also just double-click the index.html file in your Explorer or Finder as we did. One note about the console that opened down there. This debug console opened during debugging. It outputs log messages here, and you can also evaluate expressions in here at runtime to run some quick calculations or get the value of a certain variable. So whilst the debugging process is running, you can use that console here to see what's going on in your code. Now that's it for debugging and for writing efficient code. In this module, you learned a lot about how to use and utilize and configure your IDE, and make sure you really do explore the features you can use there so that you can write code efficiently. Make sure you do configure your IDE to suit your needs, both regarding its looks, but also regarding the way it works. You learned about MDN and what a great resource it is, and how to Google correctly and use Stack Overflow to find help. And you also learned about the Chrome debugging tools and how you can use your IDE for debugging to run your code, pause your code, find errors, and also, of course, make sure that the app works the way it should. These are crucial features as a developer. They're just as important to know as is the JavaScript language itself. So really make sure that these are things you feel comfortable working with, that you are comfortable working with the debugging tools. And with all of that, we are well prepared to now dive back into JavaScript, dive deeper into it, because now we don't just have the very basics about JavaScript down, but we also know how to write code, how to get help, how to debug and fix errors, And hence, we can now dive deeper into JavaScript.